A warm welcome to this platform. So in this video, let us discuss organic chemistry. The first thing, let us define what organic chemistry is. So organic chemistry is simply the study of carbon compounds, excluding any oxide and carbonate. So we can say is the study of So it's simply the study of carbon compound except oxides and carbonate. That is how we define organic chemistry. Having defined organic chemistry, let us look at the terms before we go further in our study of organic chemistry or in our discussion. Let us look at the terms used under organic chemistry. So we're going to say terms under organic chemistry. What are some of the terms that we need to know as we go on studying this topic? Okay, so some of the terms that we can look at: one, organic compounds. So the first term we'll look at organic. What are organic compounds? What are organic compounds? Okay, so organic compounds are simply compounds which contain carbon but exclude any oxides. So you can say are compounds which contain carbon excluding or except oxides and carbonates. So that is how we can define organic compounds. So organic compounds are simply compounds which contain carbon but exclude any oxide or carbonates. Then the other term that we can look at is a second term under this one. We'll look at hydrocarbons. Hydrocarbons. So as the name suggests, hydrocarbons, hydrogen and carbon. So these are simply compounds which contain carbon and hydrogen only. So we can say are compounds which contain hydrogen and carbon only. So that is how we can define this one. The next term that we can look at is homologous series. Now, before we go further, let me just give examples of hydrocarbons. So examples of compounds that contain carbon and hydrogen only. The families that we are going to look at, we have the alkanes, then we have the alkynes or alkenes, then we have the alkynes, although we are not going to focus on the alkynes, but we focus only on alkenes and alkanes. Okay, so these are examples that or examples of hydrocarbons. Another term that we look at, which is the third term in this case, is the homologous series. Homologous series. Now, what is a homologous series? So it's simply the family of similar organic compounds. So you can say a homologous series is a family of similar organic compounds. These are what we call homologous series. Now, looking at homologous series, we should be able to know, or we should, under this one, we are going to go further to look at characteristics. Okay, characteristics of these compounds that are found in the same homologous series. So we can say characteristics of the homologous series. Characteristics of the homologous series. What do compounds that are found in the same family have in common? So one of them is that they have similar chemical properties. They have similar chemical properties. Now, when you talk of chemical properties, we are just looking at the way they react. So, those that are found in the same family, in terms of reaction, they react the same. But here we should take note that there is a gradual change in terms of their physical properties. So, in terms of their physical properties, although they have similar chemical properties, in terms of their physical properties, they show a gradual change in their physical properties. And this is due to the increase in number of carbons. So, take note of that. Another characteristic that we can look at is that they conform to the same general molecular formula. So you can say they conform to the same general molecular formula. So that is another characteristic. So they come from the same formula, which is called the general molecular formula. We're going to see what that means soon. So the other one that we can look at is members from the same family have similar methods of preparation. So we can say they have similar methods of preparation in their physical properties. So when you talk of properties or physical properties, we can talk of density, melting point, boiling point. So that is what we can refer to in terms of physical properties. So you know that these are made up of carbon compounds. So as the carbon chain or the chain increases, also their boiling and melting point increases. We are going to see this where we are going. I'll get to re-emphasize on this point. Otherwise, let us look at now the families that we are going to study as we go on. So under this one, the families that we are going to look at, alkanes. We are going to look at alkenes. So these are the ones that we are going to study. Then we are going to look at alkanos or alcohol. So alkanos or alcohols. Then we are going to look at carboxylic acid or alkanoics. So carboxylic acids. Then we are going to look at esters. Okay. So these are the ones that we are going to look at. Now, just to give their general formula just at this point. So the general formula, we said families or members from the same family, they conform to the same general molecular formula. Now, in terms of their molecular formula, what is the molecular formula of alkanes? So for alkanes, CN2N plus 2. Then for alkenes is CnH2N. So these you need to know them. Then for alcohol is CnH2N plus 1. Then of course OH. Then for carboxylic is CnH2N plus 1 COOH. Then of course esters. For esters is H2N plus 1. Then we have COO. Then we have CMHM plus 1. So under this one, what does N represent? So N represent number of carbons. So N represent number of carbons. Even M here under the ester ones represent the number of carbons. So number of carbons. So make sure that you take note of these. So these are the general molecular formulas that we have for the families. So for alkanes is this one. All of them are made from that. That is compounds under alkanes all come from that. Then alkenes come from that. Alcohol come from that. Then we have carboxylic come from that. Then esters all come from that. So these are very important to know them where exams are concerned. Okay? So a functional group is just a group which determines the chemical properties of compounds. So under this one, the families we said we are going to look at alkanes. Now, alkanes do not have a functional group, okay? So these do not have the functional group. But when you talk of this, the other one, such as alkenes, so alkenes, the functional group, there's a double bond between carbon. So in other words, the functional group of alkenes is the double bond. So the double bond is the functional group. Then we have alcohols. What is the functional group of alcohol? So when you look at alcohol, each alcohol has the OH. That is how you know that this is an alcohol. So this is called a hydroxyl group. Okay? So this is called a hydroxyl group. So in other words, alcohol has a hydroxyl group as the functional group. Okay? Then when you talk of carboxylic acids or alkanoics, okay, so carboxylic acids. Now, if you look at carboxylic acid, what they have as a functional group is COOH, otherwise which can be drawn as C, double bond there. Then we have, of course, OH. So this is the functional group. Then, of course, this one can be presented as such. Okay, there's a bond between here. Okay. Then, of course, the other one, which are esters. What is the functional group of esters? So the functional group, of esters is just this. This is the functional group of what? Of esters. And of course, it's a ester functional group. All right, so that is another term that we need to know under this one. All right, now let us go to the other thing that we need to know, and that is the nomenclature. Nomenclature. What is the nomenclature? So is that simply the standardized way of naming compound? So it's the standardized, okay, standardized way of naming compounds. Okay, standardized way of naming what? Compounds. And it takes into account, so we can say it takes into account two things. One, the prefix, then two, the suffix. Now, if you want to name organic compounds, you are going to consider the prefix and the suffix. So what is the prefix? So the prefix is just found at the beginning of the name. Okay, so at the beginning of the name, you are going to have the starting part, which you call the prefix. Then the suffix is just the ending part. Okay, the suffix is just the ending part of the name. So nomenclature is the standardized way of naming organic compounds. And of course, it takes into account the prefix and the suffix. Okay, we said the prefix, what is found at the beginning of the name. And this is determined by the number of carbon in the compound. By the suffix, we are looking at the ending part of the name. And this comes from the family where this compound is coming from. Okay, so let us look at the prefix. So, for the prefix, examples of the prefix, so we are saying depends on the number of carbons. So let us start with the carbon 1. So for carbon 1 here, so this first part is number of carbons. Okay, so carbon 1, what is the prefix? So the prefix is meth. Carbon 2 is eth. Carbon 3 is prop. Carbon 4 is but. Carbon 5 is pent. Carbon 6 is hex. Carbon 7 is hept. Carbon 8 is oct. Carbon 9 is non. 10 carbon is dec. So these are the prefix. We are going to go up to 10. These are the prefix that you put in front of the name of a compound. In the case it has these, depending with the number of carbons, I mean. So if it has 1 carbon, the prefix or the beginning part of the name is meth. Then if it has 2, eth, 3, prop, 4, but, 5, pent, 6, hex, 7, hept, 8, oct, 9, non, 10, dec. I guess we are together up to this point. So this is for the prefix. Then if we are to look at the suffix, let me just put it here so that we can even look at maybe examples. If we are to look at the suffix, the suffix we said comes from the what? The family or the homologous series where it belongs. So the families that we are going to look at, we said we are going to look at alkanes. So if it's coming from alkanes, or if you are dealing with an alkane with 1 carbon or whatever carbon, the end part of the name is en. Okay, this to mean that the first carbon or the carbon with the compound under alkanes with 1 carbon is called methane. So we just add N at the end. I guess you've gotten what I'm saying. So what I'm saying is that under alkanes, if this is a family, the end part of the name, the suffix, you have the prefix. If it has 1 carbon, it's a meth. If it has 2 carbon, it's a eth. If it has 3, prop, but, pent, and if it has 10, it's a dec. But the end part of the name, which is the suffix, you add this to make the name of a compound under that family. So I said, in the case of alkanes, the first one in the series that has 1 carbon is called a methane. Then, of course, the second one is going to be the ethane. The third one is going to be the what? Propane. The fourth one is going to be a butane. The fifth one is going to be the pentane. Number 6 is going to be hexane. The number 7 is going to be heptane. Then number 8 is going to be octane. 9 is going to be a nonane. And of course, a 10 is going to be a decane. I guess this makes sense, or I guess this you are relating with this. So if we are to deal with a family that is alkanes, that is what we can say. But what about alkenes? What is the end part in the case we are dealing with alkenes? So in the case we are dealing with alkenes, the name ends with en. So going back now, in this case, there's no alkane with 1 carbon. Okay, I mean there's no alkene with 1 bond, so there's no way 1 carbon would form. Alkenes start from 2 carbon. So in this case, the first one will be ethene, then will be propene, then butene, then pentene, then hexene, then heptene, then we have octene, then we have nonene, then we have decene. So this is how it becomes. Okay, I guess we are together up to this point. Let us look at another one, which is alcohol. What is the end part or the suffix of alcohol? So the end part is ano. Okay, so the end part is what? Is ano. Now let us look at how the names will be. So if you have an alcohol with the 1 carbon, if you have an alcohol with 1 carbon, it will be a methanol. 2 carbon, it will be ethanol. 2 carbon, it will be ethanol. 3 carbon, it will be propanol, butanol, pentanol, hexanol, heptanol, octanol, nonanol. Then we have decanol. So this is how alcohol names are formed. I guess you've gotten something up to this point. Up to the next one, which is carboxylics or carboxylic acid or acids. What is the end part? The end part is the anoic. Anoic. So now let us look at, and by the way, the alcohol, the first one has 0 carbon. So you're going to look at that as we get to look at each family. At the moment, we are just focusing on the nomenclature, how they are named. So now look at this one. So here, the first one here, if in the case of carboxylic, the first one is going to be methanoic. The second one is going to be what? Ethanoic. then we have propanoic, then we have butanoic, then we have pentanoic, then we have hexanoic, then we have heptanoic, then we have octanoic, then we have nonanoic, then we have decanoic. So these are carboxylic. Okay, these are carboxylic. All right, up to the next one, which is the esters. In the case of esters, the end part of the name is anoyet. Anoyet. So in the case of the one with one carbon, and by the way, esters are named because esters are formed when the acid reacts with alcohol, but just the part of the name, how you pronounce them, in the case it is formed with an acid which has one carbon, it becomes methanoyet. Okay, methanoyet, which means, methanoyet, which means this one will become ethanoyet. This one will become propanoyet. Then will become butanoyet, part of a name. But as we go on, we are going to look at how these are named. The names, the first part of the name come from the alcohol, the second part from the acid. But otherwise, I guess you've gotten the general thing here. Okay, so this is the basic introduction to organic chemistry that you need to know. So please, if you've enjoyed the lesson up to this point, do not forget to subscribe, share to as many friends, family, so that they can also learn. And don't forget to follow me also on other platforms with the same name on Facebook, on TikTok, on YouTube. All right, so we can continue. Now we look at the families one by one. So the families that we have are 1, alkanes, alkenes, alcohol, carboxylic, esters, and at the end of the topic, we should be able to look at the macromolecules. So at the moment, we start with the first family, which are alkanes. All right, so what are alkanes? What are alkanes as the homologous series? So we know that alkanes, what I can say about alkanes, we say alkanes are carbon or are hydrocarbon. Alkanes are hydrocarbons with general formula CnH2n plus 2. This is something that you have to know. So alkanes are hydrocarbons, which means they contain only hydrogen and carbon, with a general molecular formula or general formula of Cn2n plus 2. Okay. Then the other one that you should know is that they are saturated. Okay. They are saturated. Now, what does it mean they are saturated? These are saturated hydrocarbon. And by the way, alkanes do not have the functional group. So they are saturated hydrocarbons because they contain a carbon to carbon, okay, contain carbon to carbon single bond. So they contain a carbon to carbon single bond, and that is the reason why they are saturated. Now at this point, it's very important to understand a thing as well, such as how many bonds does a carbon form? How many bonds does a carbon form? So a carbon forms 4 bonds. So around a carbon, there should be, there's a room for 4 bonds. So in alkanes, you find that all 4 bonds are occupied by hydrogen, since we say these are hydrocarbons. So there's no room for chemical attack by other atoms, and hence we are saying they are saturated. And in addition to that, as we look at these, you are going to understand that these are not reactive, they are non-reactive. They only undergo a certain reaction, of course, at a certain condition, or there are conditions at which they react. So alkanes are hydrocarbons with a general formula that you are seeing there, CnH2n plus 2. They are saturated hydrocarbon because they contain a carbon-to-carbon single bond. And of course, we are saying a carbon form 4 bonds. So in alkanes, all the 4 bonds are occupied. We know for sure where we are coming from, that in this case, N in this formula is, N in the general formula is just simply number of carbons. Okay, now let us look at the first 5 alkanes. The first 5 alkanes. I know where we are coming from. We already looked at them, but we can just do a quick. So the first 5, which means the one with 1 carbon, the first one with 1 carbon up to carbon number 5. So now, number 1 is the one with 1 carbon. So to come up with the molecular formula, by the way, we are going to focus on the molecular formula and the structure or structural formula, okay, and of course the name. So that is what we are going to focus on as we look at this. So number of carbons here, let me just write on top as number of carbons, okay, so that we generalize it like this. Okay, so number of carbons, the first one, we'll look at the one with 1 carbon. Now 1 carbon, the name is methane. You know where we are coming from. Meth for 1 carbon, N coming from the family. So now, the molecular formula, we put a 1 where there's N, so it's going to be C. Then 2 multiplied by 1 is simply 2 plus 1, that is 4. So the first one is CH4. That is called methane. Now, in terms of structure, we want to show the bonds, how they are bonded to a carbon. Since there's only 1 carbon, so you have a carbon at the center, hydrogen at the end, hydrogen. So make sure that you align the bonds nicely, okay? So a line is used to present bonds. So if you just write a hydrogen suspended without bonds, that is totally wrong. So that is how you draw the first one. Let us have a look at the second one. So the second one with 2 carbons is called ethane. As you know where we are coming from, we said the prefix for the one with 2 carbon is eth, and since we are dealing with alkanes, it is going to be ethane. All right, so the name is ethane. Now for ethane, how do you come up with the molecular formula? So you just insert a 2 there, so it's going to be C2, then H2N, 2 multiplied by 2, 4 plus 2, that is 6. Okay, so this is the molecular formula. Then of course the structure here, carbon is always at the center, and they start by putting up the carbon chain. So in other words, here we have 2 carbons joined with a single bond. So around each carbon, you know that each carbon is bonded to 4. Around each carbon, surrounded by the hydrogen. Remember, these are hydrocarbons. And don't forget to take into account the number of carbon and of course hydrogen. As you can see, hydrogens are 6. So 1, 2, 3, 4, 5, 6. Then carbon 2. Don't forget to put a bond here. And that is the reason why we say start by putting up the carbon chain first. All right. So since we are going up to 5, make sure that you go up to 3. I mean, you present the structure for 3, 4, and 5. Will you be able to draw these structures? So please go on, write the name, their molecular formula, and structural formula. That is your work. All right. Okay, let us proceed to the other things under this one. So, what are the physical properties of alkanes? So the other part that we need to look at under alkanes are their physical properties. What are the physical properties of alkanes? One physical properties of alkane is that the first 4, it is believed, the first 4 are gases. Okay, the first 4 are gases. The next 12, okay, the first 4 are gases. Next 12 are, so which means from carbon 4 up to 12 of them ahead are liquids. Then the next, or the rest, let me say the rest are waxes. Okay, so the first 4 are gases, next 12 are liquids, the rest are waxes. That is one of the physical properties. Okay. Then, of course, the other physical property is that down the group, or as the number of carbon chain increases, their melting point, boiling point, and density increases. So we can say their, or let me just say boiling point, melting point, and density increases with increase in the number of carbons. So in other words, as the carbon chain increases, you expect the melting point, the boiling point, and the densities increases. Now, these properties are important. You find questions where the compounds are listed, and now they ask you which one has the highest, let's say, boiling point. So you need to look at the one that has a lot of carbons. So take note of that. That is one of the questions that you find. Okay, so that is about the physical properties. Okay, now let us look at their chemical properties. Now, chemical properties, we said it is how they react, or when you hear of chemical properties in chemistry, think of the reaction. So these, from the start, we said they are non-reactive. So we can say alkanes are unreactive. So alkanes are generally unreactive. They are generally unreactive. What is the reason? Because the bonds between the carbon atoms, so they are generally unreactive. Alkanes, we are saying they are unreactive. So we are saying because the bonds between the bond between carbons are stable. Okay? The bonds between carbon are stable. And of course, the molecules and the molecule lack specific site for chemical attack. Molecules lack specific site for chemical, go ahead and finish, attack. So alkanes are unreactive because the bonds between them are stable. So when you ask why are alkanes unreactive, because the bonds between carbon are stable, and of course the molecules lack specific site for chemical attack. So take note of that. All right, now despite this being unreactive, okay, despite alkanes being unreactive, they undergo specific reaction, of course under specific or under a certain condition. So now we are going to look at the reactions that alkanes undergo. Okay, so we are saying we can say reactions alkanes undergo. I hope we are together up to this point. What are some of the reactions? So the first one is the combustion. Okay, combustion. Now, when you hear of combustion, just think of burning in presence of oxygen. So burning in presence of oxygen. In other words, alkanes can burn in oxygen to produce energy. Okay, so alkanes undergo combustion reaction, which means they can burn in oxygen and produce a lot of energy. The reaction is highly exothermic, very important, which means it releases a lot of energy. Now, under this one, as we talk of combustion, of course, there are different types of combustions. Okay, they undergo combustion, yes, but of course depends with the amount of oxygen present. So types of combustion therefore can be one, which we call complete combustion. Complete combustion. As the name suggests, complete combustion, which means burning completely. Now, under this one, we are saying this burns, or alkanes burn in a full supply of oxygen. So complete combustion, they are able to burn completely and of course produces carbon dioxide and water. So in other words, we are saying under this one, or we can say it occurs in plenty supply. So pay attention to the terms. They will not tell you we are dealing with you not be told you are dealing with complete combustion or incomplete combustion, which is the other one. But of course, through the terms that are used, plenty, you know that that is complete combustion. So the other term that might be used here under complete combustion is abundant or abundance. Then the other one, it can be full supply. So where you find plenty supply, full supply, or abundance of oxygen or air, just know that that is complete combustion. So complete combustion, it occurs in plenty supply, abundant supply, or full supply of oxygen. Okay? So let me just give an example here of an equation. So example, if you have methane, which is an alkane, react with, that is oxygen. In this case, what is given out? So very important to know the product. So in complete combustion, every time the product is water and carbon dioxide. That is in complete combustion. So this is the reaction of one of the member of alkanes, which is a methane, with oxygen to form carbon dioxide and water. This is called complete combustion. Now, if you look at this equation, it's not balanced, so we have to put a 2 in front here so that we have oxygen 4, then hydrogen 4, hydrogen 4, then you have 1 carbon, 1 carbon. So this is the balance equation for complete combustion. So one thing that you need to know that complete combustion occurs in plenty supply, full supply, or abundance of air, which is oxygen. And what is produced here, the product, carbon dioxide and the water, always. And at this point, I should say, all the compounds that we are going to look at, they undergo combustion, producing carbon dioxide and the water. That is in full supply. So one type of combustion is called complete combustion. Now, if there's limited amount of air or oxygen, we look at, the limited amount of air or oxygen, incomplete combustion occurs. So another type of combustion is called incomplete combustion. So the question is, what is incomplete combustion? So incomplete combustion is just where partially the compound partially burns, or they burn in limited supply of oxygen. In other words, here we can say incomplete combustion occurs in the terms that are used is limited supply. Then we can also say limited supply. You can say also short supply. Okay, so when you find such terms, limited supply, short supply of oxygen or air, just know that the one that is occurring is incomplete combustion. Like I said, you'll not be told that here you are dealing with incomplete combustion. Sometimes the question might come, what are the dangers of the organic compound, certain organic compound? Let's say this case is given is one of an alkane, or what is the dangers of burning alkanes in limited supply of oxygen? Such questions you might find them, so you should be aware. So let us look at, and I'll get to explain that. So for example here, if you have a reaction, let us use the second one, ethane. When it burns in oxygen, okay, in oxygen, what is produced under this one now, what you should know is that when a compound burns, an alkane burns in limited supply of air, what is produced is carbon monoxide and water. So coming back to the question, what are the dangers of burning this compound in limited supply of air? They produce carbon monoxide from, you know that carbon monoxide has high affinity for hemoglobin compared to oxygen. That is biology. So which means, or what it means is that it is transported instead of oxygen. And of course, when it gets to the brain or other parts of the body, it destroys the cells. Okay, so in other words, we can say it destroys the cells which needs oxygen. Instead they receive carbon monoxide, so it destroys the brain cells. In the case of the brain, that is what we can say. So these are the dangers. So when it gets to the blood, instead of oxygen, the cell are starved of oxygen and they tend to die. So in other words, it destroys the brain cell. If we are to focus on the brain cell, I guess you've gotten that. Okay, so this equation is not balanced. So for us to balance it, we just have to add a 5 here and also a 2 here, and we should be able to add a 4 there and another 6 there. I guess you know how to balance the equation, and please confirm that these are the correct numbers to balance the equation. If you don't know how to balance the equation, there is a video dedicated just on the part for writing chemical equations and balancing them. Should be able to find it on this platform if you are watching this video from YouTube. Okay, so that is incomplete combustion. But of course, in a very limited supply of air, alkanes react with oxygen to form simply carbon and water. So take note of that. We are looking at the reaction that alkanes undergo. So this was the first one, which is combustion. We said combustion, simply alkanes burns in presence of oxygen. And of course, they produce certain products depend with the amount of air present. So in the case of limited supply of air, what occurs is incomplete combustion. Okay, in the case of limited supply of air, what occurs in incomplete combustion, and what is produced is carbon monoxide and water. But in the full supply of oxygen or abundance of oxygen, alkanes undergo combustion or they burn to produce carbon dioxide and the water. I guess up to this point we are together. So we look at the second type of reaction under this one. So the second type of reaction that alkanes undergo is substitution. Okay, substitution. I bet you have an idea from the term substitution. So under this one, alkanes undergo substitution reaction with the halogens. So they undergo a substitution reaction with the halogens. Now, halogens, you just know that this is the special name for group 7 what? Elements. And these group 7 elements examples, we can talk of bromine, otherwise written as this. Then also we have choline. Okay, choline, which is also as this. So they undergo substitution. In other words, the group 7 element can substitute the hydrogen in the alkane and of course take its position. So what it means here, let me give an example of a methane, and I'll draw a structure to show that. So a methane is drawn as this, okay, okay, with 1 carbon with 4 hydrogen around. So now what happened is that if this was to react with a choline, let me put choline, and choline is represented, let us present it like this because it's a diatomic. So as you can see, there are 2 cholines there. So what happened here, the condition for this, or under, in presence of UV light, or high temperature, alkanes undergo, so you're saying or high temperature, alkanes undergo substitution reaction. Okay, so what did happen here is that this choline here will substitute the hydrogen there, okay, and which means choline will go where there's hydrogen. So it's going to be hydrogen, carbon, hydrogen, hydrogen. 1 hydrogen is gone, replaced by choline, then plus hydrogen chloride. This hydrogen that is displaced react with that. So this is called chloromethane. Okay, it's no longer called methane, but instead it's called chloromethane. And of course, this is, this is methane. Then this is choline. So choline, when it reacts, becomes chloro. So that is the reason why it is chloromethane. And we are starting with chloromethane to prioritize choline. Okay, so that is a compound. That is what you're going to have from methane. That is chloromethane. Now, what about this chloromethane? This chloromethane, this time around, we react it again with it. Again, it reacts with chlorine in the presence of UV light. So take note of the conditions or high temperature. So the conditions are very important in the exams. You'll be asked, what is a condition in which substitution reaction occur, or that type of reaction in the case you identified as a substitution reaction. So one of the condition is UV light. I mean, one of the condition, or the condition here, is UV light. So now, let's say it substitute this hydrogen this time around. So this time around you have two hydrogens substituted. So which means chlorine, hydrogen, hydrogen, then plus hydrogen, chloride. So this one is the chloromethane. Of course, this is chlorine. Then this one is going to be dichloromethane because you have two chlorine now. Then this is hydrogen chloride anyway. So di comes from 2. So in other words, 2 chlorine. Then if this one was to react again, undergo substitution, this time around, chlorine is there, hydrogen there, hydrogen there. So plus chlorine. Okay, still UV light, and of course might be high temperature. So this substitute that one. This time around we are going to have 3 chlorines, okay, and 1 hydrogen chloride. So this one is the chloro or dichloromethane, we know, plus chlorine. So this one become now tri, okay, become now what? Trichloro, which means 3, trichloromethane. So this one become trichloromethane. If this trichloromethane, now this time around, all the hydrogens are substituted, become tetrachloromethane. So that is a substitution reaction. Now, it's not only chlorine, it can be a bromine. So in the case it was bromine, when it reacts becomes bromo. So it was going to be bromomethane. Then dibromo, this one was going to be dibromomethane. This one was going to be tribromo, okay, tribromomethane, okay, tribromomethane. Then was going to be tetrabromomethane. So you follow it in that way. So otherwise, that is substitution reaction. The other type of reaction alkanes undergo is called cracking. So the other type of reaction they undergo is called cracking. Okay, so we can say another one is cracking. Now the question is, what is cracking? What is cracking? So this is simply the breaking down of large, heavier, and more complex hydrocarbon molecule. So you're saying breaking down of large, heavier, and complex molecules into lighter molecules. And of course, these lighter molecules are the ones that are on demand. So cracking is simply the breaking down of larger, heavier, and complex molecules into lighter ones. Now, the cracking, the way it is done in 2 ways. Okay? It is done in 2 ways. So we can look at 2 types of cracking. So just from here, a lot of exam questions that you are going to find. So 2 types of cracking. We are saying cracking is just a breaking down of larger, heavier, and complex molecules into lighter molecules. But how is it done? So there are 2 types of cracking. The first one is the thermal cracking. So for thermal cracking, it involves the use of heat to break down large molecules into smaller ones. So thermocracking is just a breaking down of larger and complex, or larger or complex molecules into smaller ones using heat. So again, say breaking down of larger organic molecules into smaller ones. Using what? Using heat. Okay, so that is the thermocracking, using heat. Then the other one is called catalytic cracking. So for catalytic cracking, it involves using of minimal heat with an enzyme. I mean with a catalyst, not an enzyme, please. So involves use of small amount of heat and a catalyst. In this case, to break down large molecules into smaller ones. So catalytic cracking is as a breaking down of complex hydrocarbons using less heat and a catalyst. Now, here, very important to know examples of a catalyst. So, example of a catalyst here, because this part is very important. So, an example of a catalyst here, you can use aluminium oxide or silicon oxide. So, any of these can be used as a catalyst in this case. You know that a catalyst is just a chemical substance that that speed up rate of chemical reaction, and at the end of the reaction, it remain unchanged. Very important to know that. So that is about cracking. So cracking is a breaking down of larger, heavier, and complex molecules into lighter ones. Two types of cracking. We have thermocracking, which involves use of heat to break down large organic molecules into smaller ones using heat. And of course, a catalytic cracking that involves the use of small amount of heat and of course a catalyst to break down large molecules into smaller ones. Now, the other question that you might find here in an exam is the reasons for cracking. So we look at reasons for cracking. What are the reasons for cracking? So one of the reasons for cracking is to meet demand for smaller molecules or compounds, to meet demand for smaller molecules, such as gasoline, okay? I mean, such as compounds such as petrol, diesel. These have small number of carbons. So these are on high demand as they are used in electro-based cars. Some of them are used in generators, some of them. So they are on demand, and therefore large molecules cannot be used for this purpose. They have to be broken down into smaller ones. So in other words, to meet demand for smaller molecules. That is the reason for cracking. Then the other one, you remember under non-metals that hydrogen can be made industrially by cracking. So to produce hydrogen, used in Haber process to make ammonia. Not only in Haber process, but also in hardening of vegetable oil to produce margarine. So this hydrogen is produced by cracking. Then the other thing that we can look at, just to break down large molecules into smaller ones. Okay, that is the reason for what? For cracking. Okay, I hope we are together up to this point. There's no problem up to this point. Let us proceed. Okay, let us proceed. The other part that we can look at now is the part on isomers. So let us look at isomers. The question is, what are isomers? What are isomers? So isomers are just compounds which have the same molecular formula but different structure formula. We can say compounds with same molecular formula but different structure, okay, or structural formula. So this is what we call isomer. And of course, they are formed by the isomerism. So isomers are compounds which have the same molecular formula but different structural formulas, okay? Now, alkanes, since we are looking at alkanes, so for alkanes or isomers under alkanes, so alkanes with more than, which means alkanes with 4 carbons, and above exhibit isomerism, okay? Exhibit isomerism. In other words, they can be, or they can have, they can exist in 2 or more structures. So now, the one that we are going to look at in terms of isomers here, we look at the naming of, so we'll look at branched isomers, the one that involves branches, okay? Branching of the carbon compounds. Okay, since we are saying alkanes with 4 carbons and above exhibit, here, exhibit please, exhibit isomerism, okay? So we are going to start with the one with 4 carbon and look at how we can name these isomers and only form a branched isomer. So in this case, we look at the one with 4 carbon. What do you call it? Do you remember? What do you call it? Of course, butane. So butane is like this in terms of a structure. Okay, butane is like this. Now, this is the one that we know, but so this is called butane. But this butane can also be written as, let us say we put 3 carbons like that. Then, of course, let us say we put carbon, the other carbon down here. But remember, each carbon is surrounded by hydrogens. Okay, so we draw the structure this way. We are saying isomers are compound with, okay, are compound with, or which have same molecular formula but different what? Structure formula. And I guess where we are coming from, we know what a molecular formula and a structure formula is. A structure formula is shown in terms of bonds. Molecular formula is just a condensed form. So now, let us look at this before we even name them. All right. So for the first one, let us count the number of carbons. How many are they? 1, 2, 3, 4. So if we were to write the molecular formula is C4. Then hydrogens 1, 2, 3, 4, 5, 6, 7. This is 7, 8, 9, 10. So H10. Okay. Let us count for this one. Number of carbons 1, 2, 3, 4. So number of carbons also C4. Then hydrogens 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So number of carbons, number of hydrogen also 10. You see, this is the molecular formula for this, and this is the molecular formula for this. Now, if you look at them, they all have C4H10. But in terms of the structure, they differ. And therefore here, these are what we call isomers. So butane has 2 isomers, this and this. Now, this one we know already is butane, but that is not the case of the second one. We need to name it. So now this is where we come to naming isomers. Okay? Now listen to this. Naming isomers, here we are going to look at the first thing. Rather, when you want to name isomers, make sure that you identify the chain that has a lot of carbons. In other words, the longest chain of carbons. That is the first part. So first part, identify longest or longer chain of what? Of carbon. Okay? So which one has a long chain of carbon? The one that has a lot of carbons. Now, we can consider it going this way and also going down, because these are the only chains. Here it is just one carbon. Okay, here is just one. Here is just one. But here in the middle there are two. Going this side there are three. So which one is a longer chain? Is it going this side or going down? If we are to count going this side, you find that there are how many? 3 of them. But going down, there are just 2. So the long chain here, it is this one that remains. So it has how many carbon? How many carbon? 3 carbon. So the long chain has 3 carbon. That is the first part. Now, the second part, look around what you have. What do you have? Do you have, ask yourself these questions. Do you have a branch? Do you have a functional group? Do you have a branch? Do you have a functional group? Okay. If you have a branch, you don't have any of the remaining, make sure that you prioritize the branch when assigning number of carbon or when counting. What it means is that after identifying the long chain, we are going to count this forward and backward. So counting forward, this is carbon number 1, this is carbon number 2, this is carbon number 3. Backward, this is carbon number 1, this is carbon number 2, this is carbon number 3. Now what we want, or why I'm doing so, is to have the counting that gives us the lower number in terms of carbon. So we want the one that gives us the lower number in terms of the position. So which one is going to give us the lower number? So when we count, in both cases, the branch is at 2. So what I mean the branch, after identifying the long chain, that the long chain is this one, whatever carbon is outside this line is a branch. So in other words, we have these are the branch. So the branch that we have is this one. So we want to give the lower number in terms of position of the branch. So in both cases, the branch is at carbon number 2. So we write 2, then dash. The next part is we name the branch. What is the name of the branch? Now, the branch, if it has one carbon, if it has one carbon with 3 hydrogens, is called the methyl. Okay, methyl. So the branch here is the methyl. But if it had two carbons, it was going to be ethyl. So in other words, from the prefix, we just add YL. If it has 3 carbon, it was going to be a propyl. It had 4, it was going to be a butyl, just a branch. So in this case, the branch is a what? Is the methyl. So first thing, we identify the long chain and make sure in the case of alkanes, we have a branched isomer. So we need to give the branch, we need to prioritize the branch, and by giving it the lower number. In this case, if we are to count forward, backward, you find that the branch is at carbon 2 either way. Now, what was going to happen if the branch was at carbon 1? If it was at carbon 1, we are going to follow the one that has a lower number, 2 and 1. So the correct counting was going to be the one that gives us a 1. And we are going to follow that and put the branch at 1. But in this case, in both cases, is 2, 2. So in this case, the branch is methyl. Now, what is the name of, after doing this, we look at the long chain now. What is the name of the alkane with 3 carbon? And the alkane with 3 carbon is called propane. So this branch is called 2-methyl-propane. So we've named this successively. Okay, we've named this successively. So this is called 2-methyl-propane. I guess that is okay. let us have a look at maybe another example. This time around, we proceed to look at the one that has the 5 carbons, and that is a pentane. So this can be drawn as this 5 carbon, isn't it? Oh, let me start by drawing the original one. This is 5. So around, just know that they are hydrogens. Okay, around here they are hydrogens. Make sure that each carbon is bonded to 4. Okay, to 4 bonds. Around they are hydrogens. Remember, these are hydrocarbons. So this is the what? This is a pentane. Now, this pentane can also, so this is a pentane, can also be put like this, where we can put like this. So 4 carbons here, and let me just put, so around here I'll put hydrogens, 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 hydrogens. Here I'll put a carbon, of course, around it hydrogens, like this, hydrogens, 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 hydrogens. Okay, so now here, this is single bond, please. So now here, this is also has 5 carbons. Okay, so if I were to write the molecular formula, it would be C5. C5, how many hydrogens? Should be 12. So hydrogen 12. If I were to count this also, how many? C5, H12. So the molecular formula is the same, but of course the structure differs. So the first one is the pentane, but the other form of pentane, we need to write its name. How do you write its name? The first thing, identify the long chain, the one that has a lot of carbons. And if we were to look at this, wow, to that side, and of course coming down here. Coming down, there are only 2. If we were to follow this route, there are about how many carbons? 4. Then if we were to go down, there are about how many carbons? 1, 2. So the long chain is this one. Now, the moment we identify the long chain, whatever is outside is the branch. Or sometimes might not be 1, might be 2. So whatever is outside, considered as a branch. And of course, already this branch has 1 carbon, so it is a methyl. Let us take note of that. Now, if we are to count now, let us position now where the branch is. We said you count forward, backward. So 1, 2, 3, 4. So if I were to count going forward, the branch will be at carbon what? At carbon 3. But if I were to count backward, 1, 2, 3, 4, the carbon will be at what? The branch will be at carbon 2. So it will be at carbon 2. Now, which one do we follow now? One to prioritize or to give the lower number to the branch. So we are going to follow the one with a 2 instead of the one that we say what? 3. So here the name is going to be 2, not 3. Then the branch we said is a methyl. Now what remains now to complete the name is to look at what is the name of an alkane with 4 carbon. We follow the long chain. It's called a butane. So this is called 2-methyl-butane. That is the name. I guess we are progressing, or we are making progress. I guess we are making progress. Now, what about if it was this way? So the same pentane, let's say if we were to draw it this way, where we put the, or let me put the other one here, like that. So here we put hydrogen, hydrogen there, hydrogen there. Then of course here hydrogen, down here hydrogen, here hydrogen, here hydrogen, here hydrogen, there hydrogen, here hydrogen, here hydrogen, here hydrogen. Okay, if it was like this, what was going to be the name? Now look at this. Always we look at the long chain first. So if we were to look at this, it has the 3 carbons. This has only 2 carbons. This has only 2 carbons. And therefore, we follow the long chain. So after identifying the long chain now, we are going to count 1, 2, 3. Backward, 1, 2, 3. Now, whatever is outside, we said whatever is outside the long chain is considered as a what? A branch. So far we can see two branches, this and this. Okay? So now, here, the first branch is at 1, the second is at 2. So now, how we are going to write it, we write them 1, comma, 2, showing that one branch is at 1, the other one is at 2. Then dash, what is the name of the branch? Of course, this is called a what? A methyl branch. But since there are two, going to be dimethyl, then we name that way. So dimethyl. Then what is the name of an alkane with 3 carbons? It is called propane. So this is going to be 1, 2 dash dimethyl propane. 1, 2 dash dimethyl propane. So that is how it is going to be. So that is the name of this one. Okay, I guess you are progressing. So please, if you are watching up to this point, make sure that to comment, are you getting the lesson? Or are we progressing, going somewhere? Okay, so be able to comment. And of course, yeah, we appreciate just to have your feedback. All right. Now, maybe this time around, the same propane. So propane so far has 1, 2, 3. Then let me put up another way that you can write it like this. Okay, like this. Then the other one goes on top there. The other one comes down. So you can present it this way. Okay. Now, if it was presented this way, how are you going to name this? Remember, we said the first part, identify the long chain. Them, or let us number them. 1, 2, 3. So, going forward, the branch is at 2. Or branches at 2. What about backward? 1, 2, 3. Even coming backward, the branch is still at 2. So there are 2 branches there at 2. So we are going to write 2, 2 dash. What is the name of the branch? So the branch is called the methyl. And of course there are 2 branches. So it's going to be dimethyl. Now, since we are considering this one as a long chain, how many carbons does it have? 3. And what do we call the alkane with 3 carbons? It's a propane. So this is 2, 2 dimethyl propane. Okay, the other one was 2, 1, 2 dimethyl propane. So please, you cannot say 2, 1. You start with a smaller number. Okay, so that is how you name them. Otherwise, that is where we can end in terms of alkanes. I guess up to this point, you've gotten a thing. Welcome to this platform. So we continue with organic chemistry. In this one, our main focus will be on alkenes. The first part we did introduction to organic chemistry, looking at the terms under the study of organic chemistry. Then we ended by looking at alkanes, and we covered part of alkenes. But in this one, we start alkenes from the start. So which means this is lesson 2. If you've not watched lesson 1, very important that you go through before this one. Otherwise, everything that we are going to discuss will be connected to the first part. Okay, we can start. So the first question here is, what are alkenes? Remember, alkanes, we said they are saturated hydrocarbons. And this is because between carbon, or the bond between carbon and carbon is a single bond. And that is the reason why they are saturated, which means they cannot allow more atoms to attach. They are stable, the bonds are stable. But coming to this, let me not say it's the opposite, but we are going to say alkenes are unsaturated. So alkenes are unsaturated hydrocarbons. And I guess you have an idea what it means, unsaturated hydrocarbon. So the unsaturated hydrocarbon, this means that they have, or this is because, let me say because of carbon to carbon double bond, because they have carbon to carbon double bond. Now, how does that make them unsaturated? This double bond that you are seeing here can break and of course form single bonds where other atoms can attach. In other words, here the bonds are not stable. So they can break, or the double bond can break, and more room for attachment of other atoms or other atoms here can be created. This makes them unsaturated. Okay, now that double bond is referred to as the functional group. Okay, that double bond is referred to as the functional group. Now, where we are coming from, among the terms that we looked at, we said the functional group is as a group on the compound that determines its chemical reaction. So how they react, okay? So this makes the alkanes reactive, okay? Now, the other thing that we need to look at is the general molecular formula. What is the general molecular formula of alkenes? And when we say general molecular formula, we are looking at where all these alkenes are made from. So the general molecular formula here of all the families under alkenes is CnH2n, where we said in the introduction that N refers to the number of carbons. So N refers to the number of carbons. So very important to know the general molecular formula. Okay, now let us proceed and look at the first five alkenes. Okay, the first 5 alkenes. Now, to look at the first 5 alkenes, we are going to refer to the general molecular formula as well as other concept that we learn that is under nomenclature in the first one. We said in order to name these compounds successively, we take into account the prefix and also the suffix. The suffix, we are just looking at what we put at the end of a name, and the prefix at the beginning of a name. Now, very important to remember that at the beginning of the name or the start of the name of these, that is the prefix, comes from the number of carbon. We said if it has 1 carbon, it's called a meth, that is for the prefix. If it has 2, it is called the eth. If it has 3, it's called the prop. 4, it is called the but. And 5 is called the pent. Going down, 6 is called the hex. 7 is called the hept. 8 is called the oct. 9 is called the non. And 10 is called dec. So this is what you put at the beginning of a name. In the case, it has 1 carbon, meth, 2 carbon, eth. Now, let us look at the suffix. So for the suffix, we said it comes from the family. So in this case, we are dealing with alkenes. And alkenes family, the end part of the name should end with E-N-E. And therefore, to make the name of the alkene, we put E-N-E at the end. Now, it's very important to note that there's no alkene with 1 carbon. Okay, there's no alkene with 1 carbon. So it all starts from carbon 2. Therefore, the first one in the series is ethene. We just add eth for the prefix, E-N-E for the suffix. The second one is propene. The third one is butene. The fourth one is pentene. And going down. Now, what is important here, the question might come, name the third compound in the family of alkenes. Not specifically that way, but sometimes maybe you are given the questions. That leads you to identify the family to be alkene. Then they ask you to name the third one. Now, mistake can be made where you say, okay, the third one, we are looking at the one that has 3 carbon, which is propene. But in the case of alkene, that is wrong because the first one here is the one that has 2 carbons. So the second one is propene, the third one is butene. I guess you've gotten a point there. Now, coming to the first 5, the one with 2 carbon is called ethene, but also let us look at their molecular formula. how do we determine the molecular formula? So we go to the general formula. We said ethene has 2 carbons. So we just put 2 where there's N, where there's C. So you're going to have C2. And we put a 2 where there's N there, which is 2 multiply 2, which is 4. So H4. This is the molecular formula of ethene. Then let us have a look at the structure formula. Now, when you hear of the structure formula, just think of the structure showing the bonds. And you know that in this one, or in chemistry, a line is used to represent what? A bond. So we are going to draw the structure of ethene by starting by putting up carbon chain. So we connect the carbons. And you know that between a carbon and a carbon, there should be a double bond. Having 2 carbons, which means we are going to have a double bond between the 2 carbons. Then now, we connect the hydrogen around. And very important to note that carbon form 4 bonds. The fact that we have the double bond between, so each carbon here already have 2 bonds. So each one is just lacking 2 bonds to be stable. So therefore here, around we put hydrogens. And take into account how many hydrogens? 4 of them. So you cannot exceed that number. So this is the structure of ethene. So it looks like that. The second one in the series is propene, and propene we put a 3 where there's the general formula there. You know that propene number of carbon is 3. So we put a 3 there, it's going to be C3. Then H, you put a 3 where there's N, you multiply by 2, gives us 6. So in other words here, the easy way to master this is that the number of hydrogen, hydrogen is just double the number of carbon, if that is the correct way I've put it. In other words, I'm saying 3 carbons, then you just double the number. That gives the number of what? Hydrogen. Remember, these are hydrocarbons, so they contain only hydrogen and carbon. Okay, let us proceed. So now, how do we draw the structure? So the first part, we put up the carbon chain, okay? And between 2 carbon, there should be a double bond. It can be here or it can be there. Okay, so between 2 carbon, there should be a what? A double bond. The fact that we've put it in the first part, this first carbon is already bonded to 2. So in terms of hydrogen, it only needs 2 hydrogens to be stable. And of course, you put them up, down. Then this one is bonded to 1, double bond here. So which means already bonded. The mid carbon here is already bonded to 3. So it only needs 1 hydrogen. Then the last one here is bonded to 1. So this one needs 3. So this is how you assign the carbon. So never should you put more than 4 bonds on the carbon, because carbon can only form 4 bonds. So in other words, we cannot put a hydrogen here. Okay, that would be wrong. So very important to get that. All right. The next part that we look at, so we said we are going to look at the first 5, and we have just looked at the first 2. So please, the first 2, the last one, which is the second one, has carbon 3. So go on and look at the one that has carbon 4, carbon 5, and carbon 6. These are the first 5. So make sure that you answer this part is your question. All right, the other part that we can look at here are isomers of alkenes. Isomers. Where we are coming from, we looked at isomers of alkanes. And of course, we said an isomer, we're just looking at the compounds that have same molecular formula, but different what? Structural formula. In other words, they differ in their structure, but the molecular formula is the same. Now, under this one, alkenes with 4 carbon and above exhibit isomerism. Now, what I'm going to discuss in terms of isomer here, or isomers here, we are going to look at 2 types of isomers. One, positional isomers. Now, when you talk of positional isomers, we are just looking at naming the compound depending on the position of the double bond. And the other one, of course, the one that we are going to look at is the branched isomers. So this one, as the name suggests, looking at the branch. Okay, so whatever branch will be coming out is the one that we consider. I think this is what we looked at under alkanes. So we should have a prior knowledge to this part. So let us start with positional isomers. What about positional isomers? So positional isomers, we're saying, depending with the position of the what? The double bond. And in this case, we are saying, starting from carbon 4, going up, they exhibit isomerism. In other words, here, the example that we are going to look at is butene. Now, butene in terms of structure is drawn like this. Okay, we said between two carbons, there should be a double bond. Okay, so to start with, the double bond will be here. And let us put hydrogens around. And by the way, butene, the molecular formula is that is H48. Refer to the general formula, how we came up with this one. Just insert the 4 here and the 4 there, multiply by 2. All right, so butene looks like this. If I were to put the bonds around, have I put this one? Is not supposed to be there, please. And I'm just from saying that. Okay, so this is butene. Now, if you look at this butene, and again, I draw another way of putting up this one, this time around, yeah, let me put the double bond here. Then, of course, I draw it like this. Then, of course, put this other carbon here. Let us put the hydrogens around. Let us put hydrogen around, or hydrogens around. Okay? Remember how many hydrogens are supposed to be? 8. Then, how many carbon? 4. So, this one that you are seeing here, this has 4 carbons, and also this one has 4 carbons. If you are to write the molecular formula, number of carbons is what? 4. Hydrogens is what? 8. Count. Then also this one, number of carbon, 4. Hydrogens, 8. So these are 2 compounds that have same molecular formula, but different structural formula. And for that reason, they are called isomers. Now, our main thing here is naming these isomers. How do we name them? You know from where we are coming from. In terms of this part, okay, in terms of this part, we know that this is a branched one. So this one we are going to come back for this. Or let me just put up another one different here, okay, since we are looking at positional isomers. So I'll redraw this, but this time around, the double bond will not be on the first one. Okay, I shouldn't have gone to the branched one, but either way, we should be able to get around this one. So this is another form of this, okay? This is another form, shifting the double bond. So here the double bond is right here on the first part, then it's in the middle part, then, okay. So 2 of the isomers here in terms of position of the double bond. Now let us take note of this. How do you name this first one? So now, where we are coming from, we are prioritizing the branch, which means we considered the branch first by counting number of carbons, okay, going forward, backward. And we look at now the one that gives the less number on the carbon, on the double bond. So here, 1, 2, 3, 4. 1, 2, 3, 4. Now looking at this, going forward, counting going forward, the double bond will be at carbon 1. Backward, the double bond will be at carbon 3. So which one is the proper way, or the counting that we are going to go for? It's the first one, the one that gives us a lower number for the double bond. Now what do we do in terms of naming? So we know that this is butene, and the prefix is but. Then we are going to put a dash. We put the position of the double bond, dash, then ine. So this one is named as but1-ine. So that is how we name positional isomers. And those that have watched the previous video to the end, I'm sure you are aware of this part. Now, let us have a look at the second one. So for a second one, let us still count 1, 2, 3, 4. Then backward, 1, 2, 3, 4. So going forward, the double bond is at carbon 2. Coming backward, the double bond is still at carbon 2. So either way, the double bond is at carbon 2. So how do we name this? We write the prefix but for the 4 carbon, then dash, what is the position of the double bond? 2. This is an alkene. So 2, but-2-ine. I guess this part is well explained in the previous one. So we are just going to go through quick. So let us look at the branched now. So for the branched, we have two things. 1, the double bond, and 2, the branch. So which one do we consider first? So we consider the double bond first, which is the functional group. Then whatever is going to give us the lower number in terms of the double bond, that is what also the branch will follow. So remember, where there's a branch, we said you determine the longest chain. If we are to look at going this side, the number of carbon are 3. Going down, number of carbon 2. So this means that going this side is a long chain. So it's the one that we are going to use. So 1, 2, 3. Okay? So which means whatever is outside becomes the what? The branch. So going forward, the double bond is at carbon 1. Coming, if we are to count backward, 1, 2, 3. The double bond is at carbon 2. So therefore here we go for the double bond to be at carbon 1. So that's the position of a double bond. Now to name this, after we determine that, okay, the double bond is at 1, so which means the counting, we are going to follow the forward one. This gives us the branch at carbon 2. So the branch is at carbon 2. And now in naming this, you start by putting the position of the branch. So 2 dash, what is the name of the branch? It is methyl. I guess you know why. Methyl. Then what is the alkene with 3 carbon? Is called propene. So methyl prop, okay, dash 1-ine. Let us not forget the position. So this is the name, 2-methyl prop 1-ine. Okay, so that is about isomers. This is something that we looked at in the previous video. So please, I urge you to go through that part to have the deeper understanding of this. Otherwise, we can proceed, and this time around to look at the chemical properties of alkenes. What are the chemical properties of alkenes? No, one thing about alkenes, so properties or chemical properties, so you can say chemical properties of alkenes. Okay, what I'm trying to say is that where we are coming from, we've determined that alkenes are reactive. So we can say alkenes are reactive. And the question is, what makes them reactive? So because of the functional group. So they have a functional group. Now, what is a functional group in this case? The functional group that they have is the double bond between carbon and carbon, which can break and allow attachment of other atom. And that is what we call, that is what makes them reactive. Now, what are the type of reaction that alkenes undergo? So, types of reactions under alkenes. What are the types of reactions that alkenes undergo? So one of the reaction is combustion. Okay, one of the reaction is what? Combustion. Now, combustion, where we are coming from, is us burning. Okay, so these burn to produce what? Depends with the amount of oxygen. So combustion, we can break it down into 1, complete combustion, and of course incomplete combustion. So the other one is the incomplete combustion, but we'll look at it at at a certain stage. So for complete combustion, what about complete combustion? So under this one, alkenes burn in excess. So these are the terms that you expect: excess, abundance, okay, abundance. You can talk of full supply. Then also you can say plenty. This one should be like this. So plenty supply. So any of these terms, if I use, just know that that is complete combustion. Excess oxygen or excess supply of air, full supply of air, abundant supply of air. And in this case, air, we are referring to oxygen. You know that this is the one that supports burning. All right. So they burn in excess abundance or full supply of air. And what is produced? Carbon dioxide and water. So what is produced is carbon dioxide and water. Now, let me give here an example of the first member, which is ethene. Ethene like this. Then plus what? Oxygen, or react with oxygen or burn in oxygen to produce carbon dioxide and water. So carbon dioxide and water is produced. Now you need to balance this equation. That is one of the things you are going to find in the exam. Copy and let's say balance the equation that you are given, or write the equation and balance it. That particular part you should be able to know it. If you are not aware of that, there's a video just right on this platform dedicated just on this part. Otherwise, you need to know these and also how to balance them. So let us come back to this. So combustion, complete combustion, these alkenes burn to produce carbon dioxide and water every time they burn in complete supply or in full supply of oxygen. Now, we also discussed the other type of combustion that is under alkenes, that is incomplete combustion. So incomplete combustion, simply these burn in the limited supply or short supply of oxygen, and what is produced as the product is carbon monoxide and water. So very important to know. Questions that you expect here, you find questions such as, what are the dangers of burning these organic compounds in limited supply of air or in short supply of air? Of course, they produce carbon monoxide, which is the harmful gas when it is transported in the blood. Okay, when it is taken to the cells, it deprives oxygen to the cells, and of course, they tend to die. In the case of brain cells, it damages the brain cells. So, very important to understand that point. Aside from that, the other type of reaction that these undergo is called additional reaction. So additional reaction across the double bond. Additional reaction across the double bond. The fact that they have double bond which can break and allow room for attachment of other atoms, these can undergo additional reaction across a double bond when it breaks. Now, types of additional reaction that these undergo. Types of additional reactions. So one of the additional reaction is one, hydrogenation. Hydrogenation. As the name suggests, hydrogenation, just the addition of what? Hydrogen. So hydrogenation, just the addition of hydrogen. Okay, addition of hydrogen. Okay, so addition of hydrogen, and this occurs for hydrogenation. Before we even give the reaction, let me just give of the conditions at which hydrogenation occurs. So one, there should be a catalyst. So these conditions are very important. These are questions you find. What are the conditions for that reaction? Okay, might not come as addition, hydrogenation, but of course through the reaction you are able to tell that this is hydrogenation. Then they ask for the conditions. So under this one, the condition is one, a catalyst, which is the nickel. So nickel is used as a catalyst. Then also it occurs at a temperature. So temperature is one of the conditions of around 300 degrees Celsius. Okay, so very important to take note. Now, let me just give a reaction here for hydrogenation. So generally, alkenes, when they undergo hydrogenation reaction, in this case hydrogen is added, what is produced is the alkane. So one way to convert alkenes to alkane is by hydrogenation. Remember, nickel is used as a catalyst and a temperature of this degree Celsius. I guess we are together up to this point. Now, if we look at the reaction, I'll give the simplest one in terms of structure, which is the ethene. Okay, ethene. When ethene undergo hydrogenation reaction, like we said, the double bond break. So here is hydrogen. Okay. Now this double bond break, and of course, what happened to this? It forms double bond. It forms double bond where hydrogen attach, and now you have all single bonds. You know that alkanes are single bonds. So these are hydrogens that I've added, and these are the bonds that have been created after the double bond was broken down. So this is how hydrogenation do occur. So now, the other thing that is you need to understand is the importance of this process. What is the importance of this process? So this process is helpful in converting, okay? So this process or this reaction can be used in converting vegetable oil to form margarine. These are important things, okay, to form margarine. So that is the importance of hydrogenation reaction. Otherwise, we can proceed to the other type of additional reaction, in this case, which is the hydration reaction. So, hydration reaction. Now, when you hear of hydration, think of water. In this case, you're going to consider the steam, which is just in gas form. So, in other words, hydration is just the addition of water to the alkenes in the presence of a catalyst. So, addition of water to alkenes. Now, when you add water to alkenes, result into the formation of what? Alcohol. So we can say it's addition of water to alkenes to form alcohol. Okay? Now, what are the conditions? What are the conditions? So this occurs in the presence of a catalyst. So what is the catalyst in this case? Phosphoric acid. Then, aside from phosphoric acid, we have temperature. So also it occurs at a temperature of around 300 degrees Celsius. Then we have also pressure of around 60 atm. So these are the conditions at which the reaction occurs. So generally, when alkene or alkenes, when they react with steam, in the presence of the conditions listed here, result into formation of what? Result into formation of alcohol. Okay? So propene become propanol, alkene become ethene become ethanol, and so on and so forth. So I'm going to give the simplest one for the structure. So this is the simplest one, a reaction. So this is ethene, as you know from the structure. Then, of course, here you're adding water. Then what will be the resulting? Remember, the conditions are these. You can write them: 300 degrees Celsius, 60 atm. Then, of course, on top we have a catalyst, which is the phosphoric acid. Then what is going to form here is the double bond breaks, and of course leave room for attachment of two other atoms. So this double bond is going to break, and what you are going to have now is one end you're going to have OH, the other end you're going to have H. Otherwise, this is the ethanol. So this is the ethanol. So that is how one-way alcohol is made. So very important to understand this reaction. Okay. Now, what is the other thing that we can look at? So the other type of reaction that we can look at is the halogenation. Okay? Halogenation. So also halogens are group 7 what? Group 7 elements. So they can add also. So halogenation, group 7 elements, they can add also to an alkene. Okay? So alkenes can undergo halogenation, where the double bond break and leave room for attachment of group 7 elements. So in other words, generally, if alkenes react with halogens forms haloalkene. Okay, haloalkene. For example, let's talk of the second member of, or the first member of the alkene family, which is ethene, this one. So when it reacts with one of group 7 elements, and by the way, I should have specified that can be bromine or choline or other group 7 elements. But for the sake of our study, let us just use bromine and choline. So let's say you have bromine here reacting with this. So bromine like that. So what will happen here is that this would break the double bond and of course leave room for attachment of the two bromine. Uh, So in this case, one bromine is going to attach there, one is going to attach there. And this is called, this is carbon number 1, this is carbon number 2. So this is called 1, 2 dibromo, 1, 2 dibromo, that is ethane, dibromo ethane. Okay, so that is what forms. If it was choline, it was going to form something like this, choline, that is hydrogen, 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 hydrogen. So this one was going to form 1, 2 dichloro what? Ethane. Okay, dichloroethane. So very important to understand these. Okay, so now the other thing that you need to know under this one is testing for alkenes. How are you able to tell that these are alkenes? So alkenes, when they react with bromine water, okay, so bromine water. Bromine water is red in color, or bromine solution in some cases. They will refer to bromine solution is red in color. So when alkenes are added to a bromine solution, it decolorize the bromine solution. Okay, so it makes it colorless. That is the identity test for what? For alkenes. So it decolorize bromine solution. Okay, so for testing for alkenes, when it is reacted with bromine water, the bromine water react with alkenes to form a colorless solution. In other words, it decolorize the bromine solution. So that is the identity test for alkenes. The question that you might find is that which one decolorize bromine solution? In the case they are listed. So what decolorize are bromine? Yeah, I mean what decolorize are alkenes. All right, so addition reaction here, or addition polymerization, one part that is remaining for this part, we are going to look at that under, that is macromolecules, under synthetic polymers. I think I'll get to explain this part there. But of course, we can end by looking at use of alkenes. So alkenes, they are used in the manufacture of plastics, they are used in making of bottles, they are used in making of raw material in the chemical industries. They are used in the synthesis of polymers such as polyethylene, PVC, and Teflon, and also used in the ripening of fruit artificially. Okay, so these are some of the uses of alkenes. Otherwise, we can end here for this lesson. So if you are interested to join us for online lessons, you can just call the number 0976 402563. For physical lessons, we are found in Kabwata, near Kabwata Primary School, just along 80th Street as you connect to Ring Road. Otherwise, see you in the next one. A warm welcome to this platform. So in this video, we're simply going to discuss alcohol. So this is the third lesson that we are covering on organic chemistry. So if you've not gone through lesson 1, lesson 2, kindly do so before you come to this one. And another thing before we proceed, if you've not subscribed to this YouTube channel, make sure that you do so. Turn on the notification bell that whenever I post new materials, you'll be notified. Especially those that are writing soon, I'll get to post a lot of material that can be helpful in terms of your studies and preparations. All right, so we can begin. And the first question is, what are alcohols? So alcohols are just a homologous series which contain OH as the functional group. So homologous series which contain OH or hydroxyl group as a functional group. So every time you find OH in a compound, just know that that is an alcohol. As the question that you expect, sometimes you'll be given the structures and you'll be asked to identify which of the compound is an alcohol or can come in different way. But you should be able to identify an alcohol by the OH. What is the general molecular formula of alcohol? So for the general molecular of alcohol, so general molecular formula, they have a general molecular formula of CN H2N plus 1 OH. Now, remember alkanes, this is the general molecular formula for alkanes. Then for alkenes is this one. So far we have 3 molecular formulas that we've learned so far. So you need to know that this one is the molecular formula of alcohol. So very important to know this. Now, in all cases, as we've already discussed, N represents the number of carbons. So even in this general molecular formula, N represents the number of carbons. And for alcohol, number of carbons start from 1, 2, 3, and so on and so forth, just like alkanes. But in the case of alkenes, you know that the number of carbon start from 2, 3, 4, and so on and so forth. So for this is still 1, 2, 3. Okay, so I guess you still remember this. Now let us look at the first 5 alcohols. Okay, first 5 alcohols. Now, where we are coming from, we said for you to name the compound here, we take into account of the prefix. So the prefix here with 1 carbon is called a meth. You still remember the one with 2 carbon is called eth. The one with 3 carbon is still a prop. So even here it applies. But the only thing that has changed from all these other groups that we've looked at is the suffix. So for alcohol, the suffix is ano. Okay, so which means the first alcohol is called methanol, the second is called ethanol, the third is called propanol, the fourth is called butanol, number 5 is called pentanol, 6 is called hexanol, heptanol for number 7, octanol for number 8, and so on and so forth. So that is something that you should know. So now let us just maybe try to write about maybe 2 of the structures, 2 of the compound terms of structures. So the first part here, I'll put number of carbons. Then here I'll put molecular formula. Then here, let me say here there will be name. Then here I'll put molecular formula. Then here I'll put structural formula. Okay, put them like that. Now, the one with 1 carbon, we know that. So 1 carbon, we know that is a methanol. Now, if it's a methanol, what is the molecular formula? So for molecular formula, just put a 1 in that one. So in that case, carbon 1, so it's going to be just carbon. Then hydrogen here, you multiply a number of carbon, you multiply it by 1. 1 multiplied by 2 is as 2, plus this 1 gives us a 3, but OH. So C3, then OH. This is the molecular formula of the first member. Now, to draw the structure, you put up the bonds, how they are connected. So alcohol, they are just more like alkanes, but the only difference that they have OH. In other words, what I mean is that they have double bond as well. Okay, so just that on one end they have OH. So this is the structure of methanol. This is the structure of a methanol. Now, at this point, let me just re-echo or re-emphasize the point that I've already been emphasizing on, is that you need to know how to differentiate, or you need to differentiate the molecular formula and the structure formula. So the molecular formula simply shows the atoms, okay, but not showing really where it is bonded to or where it is attached. But for a structure, you draw showing bonds. I guess this point is still in your mind. All right, let us draw the second one. So as usual, the name. The second one is the ethanol. Okay, the second one is what? Ethanol. Now, for ethanol, number of carbon 2, let me put number of carbon 2, and this is called what? Ethanol. Okay, molecular formula, you put, so the general formula is this one, plus 1, that is OH. So you just put a 2 in this one, and we are going to have C2H, 2 multiplied by 2, 4, plus 1, that is 5. So it's going to be 5, then OH. So this is the second one. Then in terms of structure, in all cases, you start by putting up the carbon chain. How many are the carbons? 2. Then around now you can put whatever is bonded. Just like I said, everything here are single bonds that you form. So OH, we can put it there, but you can put it at any carbon anyway. Okay, so that is how it is going to appear. So this is ethanol. Okay, go on and draw the number 3, 4 up to 5. This I leave it up to you. I guess there's no problem up to this point. Okay, now the other thing that we can look at under alcohol here are isomers. Okay, so isomers, just like any other compound, alcohols also can exist. You can have two alcohol of having same molecular formula but different structure formula. I guess you still remember the definition for isomers. Now here we focus on the positional isomers. Just like in alkene, positional isomers, we said these just depend with the position of the double bond. And in this case, the positional isomers of alcohol would depend on the position of the what? The OH. So alcohols have also isomers. For example, in terms of the position, please, in terms of the position. So if you have, let me say, propanol. Propanol, we can put it like this. Okay, we can draw it like this. So these are just simply positional isomers according to or depending on where the that is hydroxyl group is attached to which carbon. So it can also be like this, where we put the OH here like this. Then now these two that you are able to see the name differs. Okay, so we have something like this. So now, what is the name of the first one? So to name this one, you take into account the position of the OH. So in the first one, if we are to count forward, 1, 2, 3, backward, 1, 2, 3. We are prioritizing the OH, which means we consider it first. We want a number that is lower where there's OH. So we are going to count in this direction. So in other words, the double bond is at 1. I mean, the OH is at 1. So what do you write? So in terms of a name, it's going to be propan dash 1 O. So that is how we name this one. Then for this one, if you are to count 1, 2, 3, 1, 2, 3, you've seen that the double bond, I mean the OH is at carbon 2. So it's going to be propan dash 2 O. So these are different. Okay, so depending with the position of the OH. I guess this is something simple to understand. Okay, so go on and let me just put up a structure. Go on and name this. Okay, go on and name this. What would be the name of this? What will be the name of such an alcohol? Okay, so go on and name this one. What are the properties or physical properties of alcohol? Physical properties of alcohol. The physical properties of alcohol is that the boiling point increases with increase in number of carbon. So you can say boiling, not only boiling point, but also melting point. Also, we can talk of, so boiling point, let me put it this way. Boiling point, melting point, density, molecular weight, all these increases as the carbon chain increases. What it means is that as the number of carbon increases, even the molecular, the boiling point, molecular weight, density, all these increases. Then alcohol, they dissolve in water. So they dissolve in water. Okay. Then the other one, that they have a characteristic smell. Have a characteristic smell. Example, beer. They are colorless. So these are some of the physical properties of alcohol. What about the chemical properties of alcohol? Now, when you talk of chemical properties, I usually emphasize we are just looking at how alcohol react. So chemical properties of alcohol. One of the reactions that alcohol undergo is combustion. So when alcohol undergo combustion, it produces relatively high amount of energy. So alcohol can burn in plenty supply. Okay, can burn in plenty supply of oxygen, plenty supply of air to form or to produce. This is complete combustion, remember? So it's just the same to produce carbon dioxide and water. So this is still complete combustion. So alcohol can burn in plenty supply of air, which is just oxygen component of air, to produce carbon dioxide and water. An example that I'll give is, I guess you know this alcohol. Do you know this alcohol? This is ethanol. When it burns in oxygen, it produces, that is combustion, it produces what? Carbon dioxide and water. It's just a matter of balancing this equation where we add a 3 there, we add a 2 there, and we put a 3 there. So this is the combustion equation when one of the alcohol undergo combustion. Now, chemical properties, they all the compound, in other words, under alcohol can undergo combustion and produce carbon dioxide and what? That is in full supply of oxygen. A lot of energy is given out in this process. And of course, we know, and therefore it's highly exothermic. Now, aside from this, also it undergo, the other reaction that alcohol undergo is dehydration reaction, okay, or dehydration simply. Now, dehydration, let me just remind you of where we are coming from in terms of alcohol making, as we are going to look at some of the parts. Where we are coming from, under alkenes, we had hydration, where we are simply adding steam to alkenes to form alcohol. This time around, we are removing that water, and what will remain? We go back to alkenes. So dehydration reaction results into the formation of alkenes. So we can say alcohol undergo dehydration reaction to form alkenes. Now, what are the conditions for dehydration? So these are very important things. What are the conditions for dehydration? One of the conditions for dehydration is temperature. There has to be heat, okay, as you do dehydration. Then the other one is a catalyst. Now, at this point, what is the name of the catalyst in this case? So you should be able to specify. So this question is yours. What is the name of the catalyst? So you should be able to put your comment and I'll be able to check. So as you're answering, you put it, the catalyst used in dehydration is this and this, so that everyone will be able to know specifically what you are talking of. So now, alcohol undergo dehydration reaction to form alkenes, okay, which means the water is removed. And of course, this will occur in presence of heat and of course a catalyst. The question is that, what is the catalyst in this case? So make sure you name this catalyst. The other reaction that alcohol undergo is oxidation. Now, oxidation in this case, you know that there are different ways of defining oxidation. Can be in terms of hydrogen, oxygen, or electrons. So in this case, we are just looking at oxidation in terms of oxygen. So the addition of oxygen to alcohol is what we call oxidation in this case, or addition of oxygen. So in other words, alcohol undergo oxidation reaction and of course result into formation of carboxylic acid or acid. So alcohol undergo oxidation to form acid. Okay, so what is formed is acid. Now, when you leave alcohol in an open place with the air or oxygen in air, it undergo oxidation. So when you expose alcohol to air, where this oxidation take place, okay, so if alcohol such as ethanol is left standing in air, it will be oxidized with the help of bacteria, of course, and this form ethanoic acid. So I've given a specific example here. If you leave ethanol in an open place or standing, it will undergo oxidation, and this one result into ethanoic acid. Okay, so that is one way maybe of forming ethanoic acid. Now, this process where you just leave it in an open place is slow. Now, the fact that ethanoic acid is produced, this could be the USIF process, therefore need to be made to occur fast so that more of the acid can be produced. So you're saying ethanol can be oxidized much faster by adding an oxidizing agent. Okay, aside from just leaving it standing, it can be made faster by adding what? An oxidizing agent. So we are saying ethanol can be made to oxidize faster by adding an oxidizing agent. An oxidizing agent. Now, what are some of oxidizing agents used in this case? So you can use one, potassium. That is potassium permanganate. Okay? Potassium permanganate. Or you can use potassium dichromate. Dichromate. Let me just write a correct spelling here. So dichromate. So these are some of the oxidizing agents that are used to make this reaction fast. Now, which means if you have something like this, Okay, you want to do oxidation of alcohol. So this is a test tube. Okay. So you have here distilled or distillate, that is alcohol. Then of course here, that is where oxidation take place. That is where you add the mixture. So this is the mixture of alcohol and also whatever oxidizing agent that you are using. So let us say potassium dichromate. Okay, and you heat. There's some amount of heat that you apply here. So when this one is heated, it evaporates, and of course here there's water just to help to condense this. Okay, there's cold water. So that is how oxidation can be done. In terms of an equation, I think I've seen the question where they ask you to draw the structure in terms of how oxidation occurs. So we have ethanol is the one that we are using. So ethanol, here is ethanol. Then plus oxygen. What is produced is ethanoic acid, which is like this. So here there's hydrogen, here there's hydrogen, there's hydrogen, there's hydrogen. Then plus water molecule. So that is the oxidation in terms of structure. Away from oxidation, the other type of reaction should be the third one we are looking at. That alcohol undergo is called esterification. Now, esterification is just where alcohol react with acid. So alcohol undergo esterification where it react with carboxylic acid. So esterification is just the process by which alcohol react with carboxylic acids to form, what is formed? To form ester and water. So what is formed in this case is ester and water. So the mixture is heated gently here. So there has to be heated gently. Okay. So esterification is one of the processes that we are going to look at some point. So we'll not go into detail here, but something that we are going to cover under esterification. We'll get to look at the naming and all that. Okay. Now, let us look at formation of alcohol. How is alcohol formed? What are the ways in which alcohol is formed? So alcohol can be made, okay? Alcohol can be made by hydration of alkenes. Remember, hydration of what? Alkenes. And also fermentation. So these are the processes that we are going to look at here. So we are going to start with hydration of alkene. Hydration of alkenes. So hydration is just the addition of steam to the substance. In this case, you're adding, you're adding steam to an alkene. Okay. Now, here where we are coming from under hydration, I think we discussed that here they are catalysts. So when you are doing hydration, the alkene or whatever alkene you are dealing with is mixed with steam and of course passed through the reactor containing phosphoric acid as a catalyst. So since we've looked at this already, I can just emphasize on the part of the conditions. So hydration reaction is just addition of steam to alkanes. Okay, so addition of steam, which is just H2O, to alkenes. And what you form is the alcohol. Okay, the conditions. What are the conditions? Conditions where we are coming from, we said a catalyst. So conditions for hydration, very important to know the conditions as you prepare for the exam. So catalyst. What is the catalyst used? Phosphoric acid. Then, what is the other condition? Temperature. So temperature of around 300 degrees Celsius. Then also pressure of around 60 atm. 60 atm. So these are some of the conditions. So here, what you need to know is alcohol are formed by or can be produced by hydration reaction, where alkenes are reacted with steam and passed through the container or passed through the reactor containing phosphoric acid. In other way, phosphoric acid is a condition, temperature is a condition, and also pressure at which this hydration occurs. So very important to understand this. Questions, they can come in a scheme diagram where you have to identify these reactions, conditions, and all that. So make sure that you also look at the video that I recorded just answering questions. The video is about 3 hours, and I think that is on my trailer. When you just go on my channel, so it's the first video that you're going to see. So that video contained all the questions in organic chemistry, answered most of the questions. Let me see. So make sure you check it out. All right. So let me just put up how a reaction will look like. So in the example, you have ethene, okay? Ethene, then plus what? Let me just put maybe the structure. Ethene, otherwise as this, but I'm sure this is just a repetition of what we've looked at. But anyway, we'll go through. So plus what? Water. The conditions are what? Phosphoric acid, temperature of 300 degree, pressure of 60 atm, atmospheric pressure. Then what is formed is ethanol. Ethanol is this. This is what is formed. Okay, that is what forms. All right, the other reaction is fermentation, whereby which alcohol is formed is the fermentation. The question is, what is fermentation? So it's just a chemical, fermentation is just a chemical process in which microorganisms such as yeast, so you can say is a chemical process in which microorganisms such as yeast act on sugar or carbohydrate or glucose, let me say, to produce carbon dioxide, to produce carbon dioxide and alcohol. In this case, ethanol. Okay? So to produce alcohol. So that is fermentation. Have I seen a question where they ask you to define fermentation? Maybe. So it's just a chemical process in which microorganisms such as yeast, which means found in uh, microorganisms such as yeast act on the sugar to produce carbon dioxide and alcohol. Now, we're aware that yeast contain an enzyme called zymes. So it is this enzyme now that works. Okay? All right. Now, in terms of a diagram, what I've seen in an exam where you are given the diagram. So let me just put up, they come in different form anyway. But let me just try to put up a diagram here, how it can be presented. Okay? So let us put up this. As fermentation is occurring. So now, afterward, we'll discuss the conditions, and I'll get to explain very important points that you need to know as you go in an exam. So this is the diagram that I'm trying to bring out. Okay. Perfect. All right. So here you have some liquids here. And of course here, let me put lime water. And you need to know the purpose of each of these things that I'm putting. Then here, in this vessel, you have the mixture of, so you have yeast plus glucose, then plus glucose solution. So that is what you find here. Now, what happened is that when this mixture, what happened is that the enzyme has the yeast has an enzyme called what? Zymes. It is this zymes that act on the glucose, break it down, and in the process producing what? Alcohol, which is ethanol. Okay, produces ethanol. And of course, water, carbon dioxide. So when this reaction occurs, these are the products that you find. Now, coming to the other things, what is the function of lime water here? So you know that when the reaction occurs, carbon dioxide is produced, and lime water is used to test for carbon dioxide. So the presence of carbon dioxide turns lime water milky. So in other words, lime water can be used to test for carbon dioxide, and that helps us to know that a reaction has occurred. Sometimes in this vessel, they can be added a thermometer. What is the function of a thermometer? Simply to monitor temperature. Because as we look at the conditions, this reaction occurs at a certain temperature. What are the conditions for this reaction? What are the conditions for fermentation? 1. Lack of oxygen. Oxygen is one of the conditions. So no oxygen here. Then temperature of 37 degrees Celsius. Then also, aside from temperature of 37 degrees Celsius, we have a catalyst, which is an enzyme, zymes. Okay, so these are the conditions for fermentation to occur, and these are questions that you expect. Okay, so the thermometer, if you find a thermometer, it simply means it is used in monitoring temperature change. So very important to understand all this. What are the uses of alcohol? What are the uses of alcohol? So one of the use of alcohol is used as disinfectant, used as disinfectant. Used as disinfectant. Okay, we can talk of hand sanitizer. So hand sanitizer is one alcohol. Okay, then it is used for heating and lighting. Used as fuel. Used for heating and lighting. Then it is used as solvent. So used as solvent. So some of the industries use alcohol as a solvent because water cannot dissolve certain substances. So used as a solvent. Used as beverage. Used as beverage in beers. So these are some, I said some of the uses of what? Alcohol. What are the dangers of alcohol? What are the dangers of alcohol? So for the dangers of alcohol, one, it distorts the or impairment of or affects the central nervous system. So slows down the action of the nervous system. So you can say slows down action of central nervous system. Okay? Slows down the action of central nervous system. Damages the liver. The liver. Okay? Damages the liver. Quite a number of dangers of alcohol being health-wise, social. There are quite a number of dangers of alcohol. So another thing maybe that I've just that I want you to read on, that is on fermentation. Maybe describe, I've seen such a question, describe how fermentation occurs. Maybe how you can make alcohol from what? Cassava. Okay? Something like that. So, making of alcohol, let's say from cassava or maize, how can it be made? So that process, you need to know it. And of course, if you go through the questions that I answered, you should be able to find that question answered. Otherwise, we can end here for today. The next part, we are going to do carboxylic acids, and I hope you've enjoyed the lesson. If you've done so, please do not forget to subscribe, share to many people, okay? But if you are interested in the online lessons, you can just get in touch on the number 0976 402563 if you are interested to start physical lessons. So we offer both online and physical. For physical lessons, we are found in Kawata, just near Kawata Primary School along 80th Street as you connect to Ring Road. So if you stay in that locality, you can just get in touch and of course, yeah, you come through. Otherwise, see you in the next one. Today we do lesson 4 and mainly we focus on carboxylic acids. So if you've not gone through lesson 1, which covered which covers introduction to organic chemistry, looking at the terms and also alkanes, the second lesson is all on alkenes, the third lesson is on alcohols, and now this is the fourth lesson, which is on carboxylic acid. So if you've not gone through the 3 lessons, especially the first one, you might want to go through the first one before you come to this one. Otherwise, everything will relate to the first one. Okay. So also, if you've not subscribed to this YouTube channel, make sure that you do so that you do not miss out anything. Make sure that you share to as many people as you can. And find me on YouTube. Find me on Facebook, TikTok with the same name. Otherwise, we can start. So what are carboxylic acids? So carboxylic acid are just a homologous series of weak acid. So you're saying are a homologous series of weak acids. So carboxylic acids are homologous series of weak acid. Now, weak acid, you know that these are acids that partially ionizes in aqueous solution. And what we can add here is that they naturally exist. So naturally exist in plants and animals. Okay, they naturally exist in plants and what? Animals. What is the general molecular formula of these acids? General molecular formula. What is the general molecular formula of carboxylic acid? So the general molecular formula of carboxylic acid is C N plus 1 C H. Okay, I guess by now you know the general molecular formula of alkanes, alkenes, and alcohol. So this is the general molecular formula of carboxylic acid. And as you can see, this cut here, this part that you are able to see, that is C, this part is what we call a functional group. Okay, functional group. So what determines the reaction of the acid is that part. Now, if I were to draw or to draw the structure of the functional group, it would be like this. So this is that part. So this is the functional group. So whenever you find a compound with this, just know that this is an acid. What are the questions that you expect? Sometimes you'll be given the list of compound, then they ask you which of the compound turns litmus paper red. You know that that is a typical characteristic feature of acid. So take note of the functional group and also the whole general molecular formula. These are viable questions that you find in an exam. Okay, so what else can you look at aside from this? So this functional group, please, is called the carboxyl. It's called the carboxyl group. Okay, so that's the functional group of acid. Now, the other thing that we need to know, or that we already know, is that N in this case represent what? Number of carbons. N represent number of carbons. Now, where we are coming from, alkanes, they start from carbon 1, carbon 2, carbon 3, and so on and so forth. Alkenes, they start from carbon 2, carbon 3, carbon 4, carbon, and going up. Alcohol, they still start from carbon 1, carbon 2, carbon 3, and so on and so forth. But for acids, they start from carbon 0, carbon 1, carbon 3. So, carbon 2. So, which means the first member here has a carbon 0. Alright, now let us look at how the structure will appear. So, we are going to say number of carbons, then the name, then of course the molecular formula. Here I'll write molecular formula. Then we have the structural formula. Okay, so number of carbon 0. The name is methanol. Okay, methanoic acid, methanoic acid. This being the first member, it's called methanoic acid. What about the molecular formula? We just put in the general formula is this plus 1 COOH. So I just put a 0 where there's carbon there, which means the whole of this one will be 0. Then again 0 there, the whole of this one will be 0. So this one is a hydrogen, so you only remain with one hydrogen and COOH. So it is like this. So this is the first member. If I were to draw the structure, it will be like this. Hydrogen attached to this functional group. Okay, attached to this functional group, something like this. So this will be the structure of methanoic acid. The second one has 2 carbons, which is the ethanoic acid. So the name is the ethanoic acid. Okay, what is the structure? We just put a 1 there, so it will be C1H, that is 1 multiplied by 2 is 2, plus 1, that is a 3, then C, this is called ethanoic acid. In terms of structure, you have 1 carbon, so this carbon when we are counting carbon, this carbon is a functional group part, so only one carbon here. So we have this attached to another carbon, which is a functional group, like that. Okay, already bonded. Okay, this one is then here bonded to 3 hydrogens. So this is how this appears. So that is the structure. Let us have a look at the third one. So for the third one, has 2 carbons. So you just put a 2 in that general formula. Okay, so you're going to have propanoic acid, propanoic acid. I guess you know where the names are coming from. So that's why I said if you didn't watch lesson 1, it will be very confusing, because propanoic acid itself, the first part is a prefix. Then, of course, the second part, anoic acid, is a suffix coming from acids. Then, of course, this shows the number of carbons. Okay, so now here the formula will be, if we are to put 2 here in this one, what is it going to give us? So putting a 2 here, it will be C2. 2 multiplied by 2, that is 4, plus 1, hydrogen 5. Then this. So this is the molecular formula. In terms of a structure, you put up carbon chain first. So there are 2 carbons attached to the functional group, this functional group. Otherwise, around it, hydrogens, 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 hydrogens. Okay, so this is what we call propanoic acid. Otherwise, make sure that you draw up to 5, so you can write the ones that remains. Okay, what is the other thing that we need to look at under this one? That we need to look at our preparation of organic acids. This also, where we are coming from, we discussed this. So organic acids such as ethanoic acid can be prepared by oxidation of ethanol. So when alcohol ethanol is exposed to air, it undergoes oxidation because of the oxygen in the air and result into the formation of ethanoic acid. Where we are coming from, we said this process is slow, so to speed it up, a catalyst can be added, which is potassium dichromate, if you still remember, or potassium permanganate or potassium dichromate can be used as a catalyst. Okay, so take note of that. Then now we can look at the physical properties of acids. What are the physical properties? Now, for physical properties of acid, it doesn't matter you are dealing with the weak acid or the strong acid. So already what you know are the physical properties. 1, they have a sour taste. They have a sour taste. That is one of the typical, that is one of the physical property we know. Then what is the other one? Have the pH less than 7. pH less than 7. Turn blue litmus paper red. Turn blue litmus paper red. Okay, these are just some of them. Also, acids are colorless. Okay, these are just some of them, or these are just some of the properties. So please, as you go through this, make sure that you have a lot of properties in your mind. How do they react? We look at the chemical properties. How do they react? What we call the chemical properties. So in terms of reaction, these are acids. So the way acids react is that they react with the 1 bases to form salt and water only. So 1 react with base to form salt and water only. So pay particular attention here. These reactions, you find them in an exam, okay? Or rather, you find them in the past paper exams. For example, if you have this acid, so I'm giving an example here. If you have this acid, what is the name of this acid? That is ethanoic acid, which is aqueous. When it reacts with sodium hydroxide as a base, which is aqueous. Now, what does it result into? Okay, result into what? So you know that this one, if it was to ionize, it will remain, and you need to know ionization equation of these. Okay, so it is this that react with a sodium in the other part, and this is going to form sodium ethanoate. Okay, so sodium ethanoate otherwise appears like this, then sodium, then plus what? H2O. So react with a base to form salt and water only. Or what you need to do is to balance the equation if it's not balanced. Otherwise, that is what you obtain every time an acid react with a what? React with a base. You get, in this case, sodium ethanoate and water. So sodium ethanoate, this one is a salt and water. And in most cases, this equation, I think you don't need to balance them because they are already balanced. Let me not generalize it that way, but you have to check whether it's balanced or not. Then we know already also that it can react with a carbonate. Now, what does it form when it reacts with a metal carbonate? So it can react with carbonates to form three things: salt, carbon dioxide, and water. Okay, so let us have a look at this example. We are still using ethanoic acid, which is aqueous, react with calcium carbonate, which is the calcium carbonate, which is the solid. Now, what does it form? What does it form? So this is going to form that is this compound, this one, calcium ethanoate plus carbon dioxide plus water. Carbon dioxide is a gas, so this is what is going to form. So calcium ethanoate and carbon dioxide, water. Okay. Now, the other reaction that alcohol undergo is that react with, the other reaction that acid undergo is that they react with alcohol to form esters. Okay. So our next target, we are going to look at what? Esters. Make sure that you attend the next lesson. Otherwise, this is what we need to know about carboxylic acid. Quite a short part, but make sure that you understand each and every concept, because when you start looking at esters, I think it will get interesting. We need to know everything that we need to have every information that we've ever learned under carboxylic acids. Okay, we've come to the end of the lesson. So for those who are interested to join our online lessons, you can just contact 0976 402563. We also offer physical lessons. We are found in Kabwata, just near Kabwata Primary School along 80th Street as you connect to Ring Road. So you can still get in touch if you want to come to our physical location. Otherwise, waiting to see you in class and see you in the next one. A warm welcome to this platform. So we continue looking at organic chemistry. This is lesson 5. Lesson 1 covered the introduction looking at the terms under organic chemistry as well as alkanes. The second lesson, the focus was on alkenes. The third lesson, we looked at alcohols. Then the fourth lessons were just looking at carboxylic acids. In this one, we focus on esters. So to have an understanding on this part, make sure that you review or you look at lesson 1 to lesson 4 because everything is connected. So now, the question is, what are esters? So we can start. What are esters? So esters are just organic compounds. So esters are organic compounds that exist naturally. So are organic compounds that exist naturally. That is how you can define esters. Now, they exist naturally in what? In plants. So in plants, you can talk of the fruits, then and animals. So these are the ones that gives the characteristic smell of the fruits. For example, those are what you call esters. As you know, different fruits smell differently. You are able to tell that this is a fruit, this is a fruit, this is a fruit of this type. Then also in animals, in fats, okay? So they exist naturally in plants and the animals. But esters can be synthesized at laboratory level. Although they exist naturally, they can also be synthesized. So you can say esters can also be synthesized in the laboratory. Now, how can they be synthesized? By reacting alcohol and carboxylic acid. That is how they can be what? They can be made. Okay. So, what else do we need to know about this one? So the other thing that we need to know is the formation of esters. Since we are saying they are formed by reacting alcohol, so you can say alcohol plus or and carboxylic acids. What you're going to form is an ester and water. So that is what is formed. So when an acid reacts with a carboxylic acid, what is formed is water. I mean ester and water only. So here we want to look at the formation of an ester. So we are going to react. I say, for example, let's say we have the simplest alcohol, which is methanol. Now the structure for methanol, this is the first alcohol in the series. So the structure is this one. I mean the molecular formula is that one. Then for carboxylic acid, we look at methanoic acid. Methanoic acid, the structure, this is the first one in the series as well. It has 0 carbon. As you know, acids start from number 0, 1, 2, and so on and so forth. So now what is going to form here is an ester. But to write the molecular formula of an ester, let me give it in terms of a structure first. You see how the reactions occurs. So you have OH this side, then of course hydrogen, 3 of them, like this. So this is how it appears in terms of structure. Now this one is reacting with the acid. Let me put the functional group first. So I'll put the functional group first, which means this part first is the one that I will draw so that they are facing each other like this. This is the functional group. Then this hydrogen, I will turn it the other side. Okay? In other words, I've started with COOH. Okay? This part. All right. Now, how is it, or how is the reaction, or how does the reaction occur? So a catalyst in this one, what is the name of the catalyst that is used in this one? That is another question that you should know. What is the catalyst that is used in this case. So what is used here is concentrated sulfuric acid as a catalyst. So the conditions are very important to understand. So concentrated sulfuric acid is used as a catalyst. Now, how does a reaction occur for it to form an ester? So one thing you should know that the acid part give the OH, then this one, the H. So this is going to be eliminated as the what? But I'm not saying you do that when writing, just showing you that. So when this is eliminated, so what are you going to remain with? You're going to remain with this part attached to a carbon. So in other words, the ester is going to be C, like this. Then of course, O, otherwise attached to a carbon, like this. So this is an ester. This is an ester that is going to form. Now, plus water, please, or ester and water. What is the name of the ester? So we come back to the naming. So this is called methanol, as we know. This is called methanoic acid. Okay. Now, where we are coming from, or let me just not go there. This that you are seeing as the ester, the first part comes from the alcohol. So you remove the whole of this part of the alcohol, then you add YL. So this code is going to be methyl. Then now for alcohol, you remove the whole of this one. No, not the whole of this one. The whole of this one. Then you add this one. Okay? No, it's supposed to be O-A-T, if I'm not mistaken. So which means this one is going to be methanoate. Methanoate. Now that you have two parts, you can join them, and that is the name of an ester. So the name of an ester is going to be methyl methanoate. So that is how you name it. So the first part comes from the alcohol, where you just remove this and add YL. Then for the acid, forget about the acid, just methanoic here becomes methanoate. Then the name is methyl methanoate. I guess that's no problem. I guess there's no problem there. Let's look at the second one, or the second example. What about if you have, so I'll say example 2. What about if you have ethanol react with ethanoic acid? What are you going to have? So look at this. It occurs in the presence or a catalyst sulfuric acid, concentrated sulfuric acid. So now the structure of ethanol, you know, the molecular formula is this one. And I guess you're not surprised where these numbers are coming from. Then for ethanoic acid, how is ethanoic acid written? Otherwise, ethanoic acid is the one that has one carbon. Okay, the general molecular formula of acids, you know that is this one. Then COOH. So which means we are going to have a 3, then like this. What is going to form there? So in terms of structure, this one has 2 carbons. But of course, at the end, there should be OH, as you know. So this is ethanol. Then ethanoic acid, I'll start with this part. So here react with. Then how many carbons? 1 and 3 hydrogens. Okay. So now we have this methanoic acid reacting with this one. What did we say? The acid contribute OH. then the alcohol just H. So water is eliminated here. So we are going to have this whole structure, which is 2 carbons, joined to O, then of course to a carbon, like that. Then there, how many hydrogens do we have? Like this. Okay, that will be the structure. Now, what is the name of this structure? So the first part is ethanol. So like we said, ethanol become ethyl, then ethanoic acid become ethanoate. So the name is going to be ethyl ethanoate. So that is the ester that is going to form. Now, in terms of the molecular formula, how is it going to appear? Look at this. So for the molecular formula, you can write this in advance in the middle, which is this part. Okay, which is that part. So this part is written as COO. Okay, now you join these other parts now. So this is the center part. If you want to write the name, so I can put, or mean the molecular formula, I can put COO. Then what is behind it? We have a carbon, hydrogen 2. Okay, then we have another one, hydrogen 3. So in other words, you can even get this one. How many carbons? So carbons, there are 2. How many hydrogens? 1, 2, 3, 4, 5, which is the H5, like this. Okay, so that is how you can write it. Now ahead of it, we have 1 carbon and how many hydrogens? 3. So like this. So this is the molecular formula of this. Any problem here? I guess there's no problem writing ethyl ethanoate. Okay, let us have one more. Let me say this time around you have let me use which one? Ethanol react with propanoic acid. What is going to form? Now, ethanol, the structure is, it has 2 carbon, please. So this is the structure of ethanol. So these are very important when it comes to writing the structure for the ester. Then ethanoic acid, propanoic acid has 2 carbons. So from the general formula, 2N plus 1. So has 2 carbons, which means you put a 2 there, it's going to be a 2. Then 2 multiplied by 2 plus 1 to be H5. Then of course CH. So what is it going to form? So now let us look at it. I should have put this one in terms of structure as well. So 2 carbons. And let me start with this. Okay. So the structure for this one is C, or I should have written CH5 COOH. Then this one also I put it in terms of CH5OH. So now when this react, what is it going to form? What is it going to form? So when this react, that is the ethanol and propanoic acid. When they react, what are they going to form? So in terms of structure, it will appear like this. So these are hydrogen around. Then this one react with, I'll start with this. So this is going to be like this. Then how many carbons? Hydrogen. So this is how it appears. That is propanoic acid. This part goes this. So water is eliminated. What is going to form? This is ethyl. This is propanoate. By now we know. So the name is going to be ethyl propanoate. The first name comes from the alcohol. The second name from the acid. So we are going to have this structure. So the first part here, 2 carbons. Let me just put it nicely. So I'll just take a small arrow here, and we say carbon, carbon for the first one here. That. Then O connected to what? Connected to a carbon. Then how many carbons afterward? 2 carbons. So please put the hydrogens around. So hydrogen there, hydrogen there, hydrogen there, and also the end part hydrogen. So this is going to be the structure. Now, what about the molecular formula? So I said easy to start with this. So you write COO. Then now behind it, what is there? 2 carbon, 5 hydrogens. So C2H5. Then ahead of it, 2 carbons, 5 hydrogen as well. So it's going to be, so this is the molecular formula, otherwise known as ethyl propanoate. Is there any problem up to this point? So what is important here is be able to write the molecular formula of the structure that you are given, and also be able to draw the structure formula. Also be able to write the reaction, this presenting it in this form, showing what is eliminated. So please, there's water at the end there. That is what is important here, and also be able to name. And when you are given the name, you should be able to tell what were the reactant. For example, if you are given ethyl butanoate, for me, I know that the first part, the alcohol was ethanol, and the second part, the acid was butanoic acid. I think it's as easy as that. So the first part comes from the alcohol, the second part comes from the acid. I guess we have no problem up to this point. Now, let us have a look at the chemical properties of esters. What are the chemical properties? So, chemical properties of esters. What are the chemical properties? 1, they undergo hydrolysis. They undergo hydrolysis. They undergo hydrolysis. Okay, so hydrolysis is just the addition of, okay, so hydrolysis, you add water, which means you are breaking them. We are breaking the ester. So when you break down the ester, you know that water is lost when forming ester. So when you add water, in other words, hydrolysis results into formation of the acid and the alcohol. You are just breaking the molecules that reacted. So now hydrolysis, this process can also be used in making of soap. So hydrolysis to make soap, and this is when it occurs in the presence of a base. So hydrolysis simply adding water to break the ester into its individual component, but when it is done in presence of the base, it is called saponification, the process that is used to make soap. So that is about hydrolysis. Then the other one, esters also undergo combustion. Esters undergo combustion. Now, in the full supply of oxygen, what is formed, is carbon dioxide and water. So ester undergo combustion. So have a look at some more chemical properties of these esters. But we can end by looking at the uses of esters. What are the uses of esters? 1. Esters are used to make artificial flavors. So we can say used to make artificial flavors such as spice and all that. So they are used to make artificial flavors and of course other essences that are used in the food. Aside from that, they're used in making of perfumes. So used in making of perfume. So the question, sometimes you find the question such as, let's say you are given the list of the compounds, then they ask you which one is used in the making of perfume. So you should be able to tell that this is an ester, and you know the structure of an ester. You should be able to identify this is an ester, and of course this one is the one that is used. Aside from that, they are used in making of plastics, used in making of plastics. What is the other one? They are used in making of soap and detergents. So used in making of soap and detergents. What are some of the uses? So be able to list them in the comment section. List as many as you can. Otherwise, there are a lot of uses that we can look at. So this brings us to the end of the part esters. The next part that we're looking at, we'll start looking at macromolecules, where we are going to discuss polymers, that is synthetic and natural polymers. Under synthetic polymers, we'll get to look at polymerization, that is synthetic polymerization, that is additional polymerization. Then examples here, we'll look at nylon and terylene. Then, of course, under natural, we'll look at proteins, carbohydrates, and fats, and we'll get to relate the natural and the synthetic. We should be done with the topic. Thank you very much for staying up to this point. So please, if you are interested to join us for online lessons, you can just get in touch on the number 09762563. If you are interested to come for physical lessons, we are found in Kabwata, just near Kabwata Primary School. So if you stay in that area, you can get in touch, and of course we can give you direction. Otherwise, see you in the next one. A warm welcome to this platform. So we continue with organic chemistry. This is our lesson number 6, and in this one we focus on macromolecules. So we are going to focus on macromolecules, everything around this part. So the first part, let us know what macromolecules are. So for macromolecules are just giant molecules formed by joining smaller units. So we can say are giant molecules formed by joining smaller molecules. And these smaller molecules are called monomers. Okay? These are called what? Monomers. So macromolecules are simply giant molecules formed by joining smaller unit, otherwise known as monomers. Now, macromolecules are produced by the process called polymerization. So they are produced by the process called polymerization. And polymerization is simply the joining up of the smaller units called monomers to form large molecules called polymers. So macromolecules are formed by polymerization, and polymerization is just the joining of smaller molecules called monomers to form polymers. So polymer is a giant molecule. Okay, poly, a lot of monomers. So polymers. Now let us have a look at the types of the types of macromolecules. So we look at two types of macro. What are the two types of macromolecules? So two types of macromolecules, they can be put as one. We have the synthetic. So macromolecules, they say they are called polymers. So in other words, here we can say two types of what? Two types of polymers. Okay, two types of polymers. So two types of polymers, we have synthetic polymers. Now, synthetic, without wasting time here, synthetic just means man-made polymers. So these are man-made polymers. Then the other one we can look at is natural polymers. So natural polymers existing naturally. Okay, so we are going to look at each of these. So we are going to start with synthetic polymers. So like I've already said, synthetic polymers, these are just polymers that are man-made. Okay, these are just polymers that are what? Man-made. So for synthetic polymers also can be into two. So two types of synthetic polymers. What are the two types of synthetic polymers? So one, we have what we call for synthetic polymers, we are saying there are two, and we have what we call additional polymers. Additional polymers. These are just simply made by adding unsaturated compounds, or I can be specific and say by adding unsaturated molecules. In this case, this is formed when alkenes react. So alkenes undergo additional polymerization. So when you deal with additional polymerization or additional polymers, just know that we are going to look at the polymers that are formed by alkenes. Then the other one we'll discuss it later, which is condensation polymers. So I can just maybe include it here. Condensation polymers. Now, condensation polymers, as the name suggests, so these are polymers that are formed, but in the process, there's elimination of water. So we'll get to dig deeper when you get there. But at the moment, we can start with additional polymers. So as the name suggests, additional, so which means we are just adding, okay? You are just adding the smaller units. So additional polymers here are just polymers that are formed by joining a smaller identical or unsaturated monomers. So are simply polymers formed from smaller, okay? So polymers formed from smaller identical unsaturated monomers, okay? In this case, alkenes. Okay. Now, let us look at the examples. Let us look at the examples. So, for example, so pay attention on this part because the question do come either you have to write the structure of the polymer formed or you are given the polymer, then they ask you of the monomers that or the initial monomers. So an example of the polymer that we'll look at is polyethene. Now, as the name suggests, polyethene. So poly, which means a lot of ethene molecules added to form polyethene. Now look at this. This is ethene. then another ethene, I can add another ethene. So 3 of the ethene here, adding. And let me just emphasize, one thing that you should know about this is that only a polymer is produced. So now, you know that the double bond in the alkene breaks, and when the double bond breaks, there's room for attachment of other atoms. So this one is going to attach to this. So the double bond, when double bond breaks, is going to attach to this, also that one to that. So you're going to have a polymer with 3 subunits. So 3 subunits, they have 6 carbons. So I can draw the carbons joined with the single bonds. These are 5 of them. So 1, 2, 3, 4, 5, 6. Then I can leave a space at the end. All these parts occupied by hydrogen, 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 even down there, hydrogen, hydrogen, hydrogen. Okay, so this is what we call polyethene. And in this case, I'm showing how many? 3 subunits. So sometimes you'll be taught specific number of subunit to show. In general, so if you have an alkene, that is ethene, in this case, this number represents number of subunits, resulting into a polymer, which is polyethene, with a lot of subunits. So to show that it's a continuous chain of this, you just put it like that. Then of course you're going to write N. So N represents the number of subunits there that are joining. Okay. So otherwise, this is the polyethene. What is the use of polyethene? The uses of polyethene. So this is very important to note that even as the number of carbon increases, also the texture of these changes. So for example, the polyethene is a soft, it makes soft plastics, and therefore they are used in making of plastics and or even making of squeezing bottles. Anyway, away from this, the other thing that would look at, maybe the other example, let me say example number 2, still looking at the additional polymers. In this case, let me give a different one and let us look at polypropene. Now, I want you to understand something. Sometimes the structures might be given, so confusing to know what is the monomer. So now, propene, we know that is drawn like this. Okay, that is propene. I guess you'll still remember. So propene is an alkene with 3 carbon, but at least you know that between 2 carbon, there's a double bond. So this is propene. Now, when it comes to presenting this one, where additional polymerization is concerned, you want to expose the double bond, and therefore the whole of this subunit, you write it more like it's a hydrogen right down here. So you write it down here. And how do you change this one? So this whole one is going to be, how many carbons does it have? 1. How many hydrogens? 3. So it changes to this. So in other words, propene, you're going to draw it like this. We are saying want to expose the double bond. So you draw it like this instead of putting it like that. So which means another propene I can add here. That is another propene. This is another propene. Okay, let me just put 2. So now when the double bond here break, when the double bond break here, there's going to be room for attachment of other atoms. So this is how it is going to be. So which means the polymer in the straight chain will have 4 carbons like this. Then don't forget this, you leave it open. We have hydrogen, 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 hydrogen. Then there you leave it open. Now, not hydrogen here, please. Look at this. And also here is not hydrogen, but something like this. Have you seen the way it appears? So this is polypropene. This is polypropene. How many subunits here? 2 units. Okay. Now, sometimes you might be given something like this. Let me put the same one. You might be given this instead of writing the polymer. So you are given the polymer, the same one. Okay. I want you to understand something, especially on how you determine the subunit. Okay. If you are given the polymer, how do you determine the monomer? So here it is. Now, if I ask you, what is the initial polymer? I mean, what the initial monomer? You have to cut this into 2 and just consider this one and count the number of carbons. So number of carbons, we have 1, 2, including this one, you count it. So 3. You know that alkenes are the ones that are form these polymers. So already you know that it was an alkene that reacted. But what is the name of the alkene with 3 carbon? And that is propene. Okay. Now, what about if you are given something like this as a polymer? Let me say something like this. No. Something like this. Then here we have C3. And there you have C3. Hydrogen. Hydrogen. Then, okay, let me put it like this. There you have also C3. Hydrogen. Hydrogen. CH3. CH3. Hydrogen. How many are these? 1, 2, 3, 4, 5, 6. Okay, so you have hydrogen, CH3. Then the question is, from which monomer, or what is the monomer of, what was the initial, the initial monomer for this one? Or what is the monomer from which this polymer was formed? So now what do you do? Like I said, the strategy is to cut these into 2 carbons, because you said when forming these, always you expose the double bond. So no matter how long the chain is, you're going to orient it where you expose the double bond. So only 2 carbons here. Then now, whatever remains can be up or down. So that is your target. So when you cut one of the piece here, which is CH3, carbon, then carbon, again CH3, you are going to count the number of carbons. How many are they? So number of carbons, we have 1, 2, 3, 4. So this was butene. Okay? This was what? Butene. So the subunit was butene. Now, if you are to look at it, it was a butene like this, which means this side, there's a hydrogen here, a carbon that is like this, because the double bond is in the middle. This is what it means. Then butene, is it 4 carbon? 1, 2, 3, 4. Yeah. Like this. Then here also like that. So it was this double bond here, that is 2. It was this double bond here. So which means this one was just written down like that. And also this one was written down like that. So forming this that you are seeing. But otherwise, that is how you identify it, or how that is how you identify the monomer. So very important that, because these questions are some of the questions that you find. So that is how you can look at it. I guess you've gotten a thing here. Okay. Do we need to look at more here? What about we look at another example here of an additional polymer. This time around, we look at PVC. So PVC, so example number 3 for the polymer, additional polymer. So we look at PVC, polyvinyl chloride, otherwise PVC. Okay, which is also known as the polychloroethene. Polychloroethene. This is polychloroethene, please. How about this one? So for this one, the structure is this one. Okay, so it just have a choline in it, like this. Then plus another chloroethene. So when this join, it is going to form a thing like this, which is polychloroethene. Okay, so this is an important polymer, which is called polychloroethene, an important polymer that is used in making of plastics, paint. What else is PVC used for? Making waterproof clothing, electric cabling, and all that. So these are some of the use of that is polychloroethene, which is PVC. All right, you should be able to look at also classification of plastics. So make sure that you look at this part. Otherwise, we can look at the other type of synthetic polymers, which are condensation polymers. Now, condensation polymers, we know that these are formed by elimination of water. So a condensation polymerization involves 2 subunits. Okay, so we can say involve 2 subunits which combine to form a polymer, and in the process water is eliminated. So there's an elimination of water here. So condensation polymer just involve 2 subunits which combine to form large molecules with elimination of what? Water. What is more important here is to look at the the condensation polymers here. One of them that you are going to look at is the nylon and also terylene. These are examples of terylene, please. Terylene is this, the spelling. Okay, so these are the ones that we are going to look at. So we'll start by looking at nylon. What about nylon? So nylon, what is important here is the monomers that are formed. So nylon is a tough material. And in this case, like I said, what are the monomers? So nylon, we can say, is a polymer of two different monomers. So nylon is a polymer of two different monomers. Like I said, pay attention to the monomers. Diamine, that is diamine. Otherwise, in terms of structure, we just put it like this. So diamine, which means it has an amine group. Let me just put, it has an amine group. Amine group is this one. Now, in terms of structure, we can draw it like this because sometimes you'll be asked to draw the monomers of this. So diamine is like this. This is diamine, which means two amine functional group at the end. So this is diamine. So monomers of diamine and dicarboxylic. These are the monomers of nylon. So dicarboxylic, otherwise the functional group of dicarboxylic is, the carboxyl group at the end is this one that we already know. This is the functional group at the end. Now, how does it look in terms of a structure? So let me just put a different part here. So it looks like this. This is the dicarboxylic. So it is this and this that react to form nylon. So let us look at how we can put them. So we have this. I'll start with amine. Then, of course, reacting with dicarboxylic. Okay, so here I can put another functional group here, like that. Then here I can add another amine, like this. So a lot of them join, and what is formed is what we call nylon. Okay, so at the end I can just leave it open like that. Now, how does a reaction occur? So here, the reaction, how it occurs, this hydrogen together with OH there is eliminated as water. Also here, that water is produced. That is condensation reaction. Now, how does the structure appears when they join? So it is this part that joins to the carbon there. Also, this part joins to there. Let me just try to draw how the structure appears. So we are using this. Okay, I'll use different colors, so it is going to appear like this. I can put the hydrogen down like that, then connected to what? Connected to this, then another one we can connect it there, which is like this. like this. So I can put these to differentiate them like this. So it can be a continuous chain. So now what we are interested in, so this is how the polymer appears, can be a continuous chain of these. And I'm sure you've seen these in the past papers. Now, again, the other thing that we are interested in is to know what is this linkage. So this is called a linkage. What is the name of the linkage? So questions that you expect, what is the name of the linkage? And also draw the structure of a linkage. So to draw the structure of a linkage, the linkage is simply looking like this. So if you're asked to draw the structure of a linkage, this is what you just put up. And this is called the amide linkage. Otherwise also known as what? The peptide linkage. And now, very important to understand is that on the natural polymers, we are going to find another one that has this kind of a linkage. So take note of it, amide linkage. As we go on, make sure that you come back to this one. So that is about nylon. Now, what are the uses of nylon? Uses of nylon. What are the uses? What are the uses of nylon? So, nylon is used in the making of clothes. So, making of clothes. Making of ropes. Making of ropes. So, what are some of the uses? So, make sure that you do comment in the section, in the comment section, some more uses of nylon. Otherwise, you can proceed to look at the second one, which is the terylene. What about terylene? What do you need to know about terylene? So, for terylene is a polymer which is formed by condensation. That one we know. Now, also under this one, what is important is to know the subunits. You know already that it is formed by condensation, polymerization. Now, terylene is made of two different monomers. That is what we are interested in. Two different monomers of hydroxyl, which means OH, of hydroxyl and carboxyl. Now we know that carboxyl is this. So terylene is made of two different monomers of hydroxyl and carboxyl. Okay, so let us look at these. So hydroxyl, this hydroxyl looks like this. Let me try to do this. Looks like this. Then here you have this. So this is the hydroxyl. Then the carboxyl, like this. Like this. Okay, so when these two react, that is what result into, not two or a lot of these react, that is what result into what we call terylene. So let us look at how they join. So you have the first one here reacting with Then, of course, like this. Another one here. Okay. So if you have such, we said this is condensation. So the joining result into the formation of the bond, or elimination of water, result into the formation of the bond, and water is eliminated. So this carboxyl group is the one that contribute the OH. Then of course the other one, which is the hydroxyl, is just the H. So even right here, this. So in the process, we are saying water is eliminated, but how is the structure going to be? So in this case, let me shade these. Let me shade these. So we are going to have something like this. So when this is eliminated, this carbon will join, it will join direct there. So how is it going to be? So it is going to be like this. And I hope everyone here is following. So this is how the polymer is going to be. So repeating units. I'm sure these are some of the things that you would have seen in the exams. So now, again, the interest, what is the bond? Or how can you draw the bond? So the bond is this one, or the linkage. This is the linkage. Okay. So what is the name of this linkage? So this linkage is called ester linkage. The linkage is called what? Ester linkage, and that is how you draw it. So this, the whole of this, if you see something like this with ester linkage, so the linkage, I think, should be able to help you to identify the polymer. So that is called ester linkage. What is the use of terylene? Also used in making of clothes. It's also used in making of clothes. Aside from that, can be turned into. Okay, so this is just the same as clothes. Can be turned into the fabric that can be used to make clothes. So find out some more uses of this and also be able to contribute. Now, we continue, and the other thing that we can look at here is pollution caused by polymers. What are the pollution caused by polymers? So one of the pollution caused by these is air pollution. How does they cause air pollution? We said these are plastics, okay, or they are used in making of plastics. So let us imagine the plastics. How are they recycled? Some resort to burning them, and when they are burned, they produce the smoke that contain some harmful gases. As a result, they cause air pollution. When the plastics are dumped on the environment or just on land, causes land pollution. But one of the major pollution here, we can talk of air pollutions as we try to recycle them. So that is another thing that you need to look at. Now, what are the advantages? What are the good part of having synthesized or synthetic polymers? What are the advantages of synthetic polymers? One, they are durable. Okay, they are durable, easy to use, light. They are thermal and electric insulators. They are flexible to use, as I've already said. So these are some of the advantages. But again, you can look at the disadvantages, the bad part of these, or the disadvantages of the synthetic polymers. One, they are non-biodegradable. Non-biodegradable. Now, I've seen a question here, what it means by non-biodegradable. What does it mean, non-biodegradable? It means they cannot be decomposed by bacteria. So they are non-biodegradable because they cannot be decomposed by bacteria. Okay, that is one disadvantage. Then when they are burned, it produces pollutants, so they pollute air when burned. So another disadvantages. And why people resort to burning these, we said because they are difficult to recycle. Now, bringing us to the other thing now, what are the reasons? What are the reasons for recycling these molecules? What are the reasons for recycling plastics? What are the reasons for recycling, which means reusing them? Why not burning them? Why not burying them? So, one of the reasons for recycling is that they are difficult to dispose of. They are difficult to dispose of. They are difficult to dispose of. So, you resort to reusing them. Okay. I think that is the main. Okay. What could be other reasons for recycling these plastics? The other reason why the other reason for recycling is because I think I said this already. We are saying they are difficult to dispose of, and also we don't want to burn them because they'll cause air pollution. We don't want to throw them out. They'll cause land pollution or water pollution yet. So those, if you think in those lines, then it's just okay. Okay, I think that is where we can end in terms of synthetic polymers. What we can look at now are natural polymers. What are natural polymers? So these are naturally existing polymers. And one that we have, or natural polymers that we have, one, proteins, carbohydrates. So natural polymers that we have, proteins, carbohydrates. Then we have lipids. These are natural polymers that we have. Now, looking at proteins, we are not going to go into biology where we discuss the uses of proteins, this and that. I think our main concern here, so we are going to start with proteins, please. Like I said, we are not going to go into detail describing what protein is, or the uses of protein. But instead, we just go direct to look at the basic units of proteins because that is what we're interested in. So proteins are made up of amino acids. So that is what we're interested in. So amino acids. Now, an amino acid has a carboxyl group and also an amine group. Okay? At one end, it has the carboxyl group. The other end, it has the amine group. So let me just maybe an example of an amino acid looks like this. Okay? So where you find it has a carboxyl group at the end and also an amine group at the end. So something like this. So this is an amino acid. As you can see, at the end there's a carboxyl group. The other end is an amine group. So now, protein is made up of amino acid, and about 20 amino acid, they combine to form proteins. So in this case, what we are interested in is just to show the reaction of these amino acid and the bond that is formed. So let us have this example. Okay, it's an amino acid. So joining with another amino acid. So a lot of amino acid, when they join, they form a protein. So now, you orient them in such a way that the carboxyl group of one amino acid faces the amine group of the other amino acid. This is what I mean. So we can have this. Okay. So as you can see, this is the amine group of this amino acid. This is the carboxyl group. And of course, okay, they are facing each other. So what happened? For these, they react. Remember, this is also condensation reaction because water here is eliminated. So this and that is eliminated as water. So which means what you are going to form is the bond between, and be able to remember the bonds that we've looked at. So what is going to form is this. Just put this. So here that part goes. So you are remaining with this, then attached to this. So you're going to have this. Then of course I can put the hydrogen like that. Can put this, that. Then we have something like this. So now, what bond is here? So the bond that you are able to, or that you should be able to see, is this one. And what is the name of this bond? Remember where we are coming from. This is an amide. Not the bond, please, but the linkage. This is an amide what? Linkage. Or peptide linkage. You remember which synthetic polymer or artificial polymer had this? Which synthetic polymer had the same bond as this? Those are the questions that you expect. Okay, so if you look at it, if I were to go back and just to check, I underlined it at some point, not this one. Where is it? Amide linkage. So this one was on iron. If you look at this, does it look the same as the one that we are dealing with? This one, of course. So nylon as a synthetic has the same linkage with proteins. So take note of that. All right. Let us look at lipids. What about lipids? What are the subunits? So lipid is made up of fat, acids, and glycerol. So these are the subunits, fat acid and what? Glycerol. Now, in terms of a structure, it appears like this, fat acid and glycerol, and also pay attention to the what? The bond. So, like this. This is the whole glycerol. Then you have 3 fat acids joined to this, otherwise joined like this, with a long chain. something like this. So now pay attention to the, so that is a fat acid, or that is a lipid. So a lipid is made up of glycerol and fat acids. So these are fat acids. Fat acids. Also, this is a fat acid. That is a fat acid attached to the what? The glycerol. Now, what is the bond? The bond that is there is this one. And which one on the synthetic has the same bond as this one? So if we are to look at this, the one that has that bond is this one, which is the pterylene. So on the synthetic, so synthetic is pterylene, has the same bond as lipids. So these questions are the ones that you expect. So take note of that. We can end by looking at carbohydrates. What about carbohydrates? So carbohydrates, what are the polymers for this? What are the monomers for this? What are the monomers for carbohydrates? So carbohydrate is made up of glucose. Okay, let me say repeating units of glucose. Repeating units of glucose. So now you have a glucose like this. So this is a glucose molecule or monomer. So repeating units, which means glucose, glucose, glucose joining. So it forms like this. Also is a condensation polymer because water is removed. Oh, why am I joining them already? So when you find this structure that I'm going to draw in an exam, just know that that is glucose. I think glucose is different from all. You will be able to, I mean carbohydrates, you'll be able to identify them easily. So now what happens? So here they join. Water is removed. Water is removed. And what you are going to find in the exam is something that looks like this. I'm sure you've seen this in the exam. Continuous chain like this, but at least you have an idea of what I mean. So this is called carbohydrate. So when you see such, they ask you what is the polymer. The polymer is what? The carbohydrate. Now, what is the monomer from which, or draw the monomer from which it is coming from? So to draw the monomer, you just put up this. This is the monomer. I guess you've gotten that. So a monomer, where it is coming from, the structure is this. Then the polymer that comes out looks like that. And the polymer is called carbohydrates. And by what process is it formed? Condensation reaction. Now, what is the name of this bond between? This is called glycosidic bond. Okay, it's called glycosidic what? Glycosidic bond. And this, or glycosidic bond. If we were to draw the linkage there, I think we just put something like this. I hope we are together up to this point. All right. I think this is what is important for you to look at as you prepare for your exams. Now, it has been a long journey from the start of the topic. Just a recap of what we looked at. So, we defined what organic chemistry is. We looked at the terms under the study of organic chemistry. I'm sure by now you know them, which is just hydrocarbons, homologous series, functional group, and all that. Then afterward, we looked at the prefix and the suffix, that is nomenclature, how to name the organic compound, which just takes into account the prefix and the suffix. We started looking at, or we looked at alkanes. Under alkanes, we looked at the reactions that alkanes undergo. Then we looked at alkenes. We looked at alcohol, carboxylic acids, esters, and now today we've just concluded with macromolecules. So this is a full coverage. The only part that is remaining is on fractional distillation of crude oil. Make sure that you look at that part, and also focus on cracking. When you are given the product, how do you determine the molecule that was cracked? Or if you are given the molecule, how do you determine the product formed? Now, this is a coverage in terms of a topic, but I have also another video where I did all the questions, and of course the video is just right here. So what I'm going to do, I'll put everything in a playlist so that you can easily find the recordings. Otherwise, we can end here and see you in the next topic. But before we go, if you've not subscribed to this YouTube channel, make sure that you do so. And if you are interested for online lessons, you can just get in touch on the number 0976 402563. If you are interested for physical lessons, you can visit us. We are found in Kabwata, just near Kabwata Primary School. If you stay in that area, you can still get in touch on the same number. If you stay in that area, you can get in touch on the same number. Otherwise,